Should pop up as live in a second here. That is. Yep, there we are. Starting soon. Oh, of course, and we should share it in the holochain chat.
Yes. Well, I guess Facebook is actually pretty good at the multiple sort of brand identities with one person with their like pages.
Right, because they've actually split. Um, they've split projects from people. Like only individual people are supposed to have regular accounts,
right?
And only projects are supposed to have.
But they have a way for you to manage brands.
Right, and so
Twitter does not have that.
Right, so Twitter could easily just say, you know what, some accounts can be in charge of other accounts.
Yep.
It could be the owners of other accounts.
Yep.
And it could work the exact same way.
Yep.
Which honestly, they should do that. Why not?
I agree. I think that would be great. Instagram kind of has that.
I don't know anything about Instagram.
From Facebook.
Right. Cool. Okay, so here we are.
Hey.
Wow. Professional.
Very professional. If anything, that's what we are.
Yeah, we are nothing if not
professional streamers.
Welcome to our professional stream.
Yeah. Super pro.
Professional stream number 4, maybe 5.
Yeah. We have almost 300 views.
And that's more people than I have. That's more than I have like friends in real life.
Yeah.
So that's a success.
Huge success. All right. So you have you got those notes up. Cool.
Yeah, so here we are. So this is kind of our plan for today. We've got two real code bases here that are progressing past the proof of concept stage and starting to be things that might actually be usable by people. You know, maybe they'll fall apart and we'll have to redo it a different direction, but so far they seem good. One is Squad, which is kind of the Steam-esque thing in the set match games ecosystem. There are definitely some big differences, but that's a good mental model for it. The other one is the first try at an actual game, which is a very simple game, Roshambo or rocks, paper, scissors. So trying to make an implement that can be played on holochain, first of all, and then that we can use as a game to register in Squad.
Yes. And so we're going to need a few changes to both Roshambo and Squad in order to get them to play together. Squad needs a strategy for actually accepting games like Roshambo, and then Roshambo needs to implement things, formats, a way to play with formats and components so that the community can contribute other components than rocks, papers, and scissors, and the community can curate formats like, say, Lizard and Spock, and then a rocks, paper, scissors, Lizard, Spock format. And then the game code itself needs to be able to work with new unknown components that are made in the future. And then Squad needs to be able to launch that, having chosen a format and to play with.
Yeah, so there'll certainly be a lot of things for us to do here,
Yep.
but in theory, we should be on the path to a functional version of set match games that has at least one game that
Yep.
will be fully fully customizable and curatable by the
Yep.
community.
Yep.
Which, even though it's a very simple game, could be fun and
Yeah.
exciting to see.
Yeah. So yeah, I think um, I think we should start with Rochambeau, looking at the game,
Cool.
and then because there's a few sort of I think the things are clearer there. The things we need to figure out are clearer
Right. Yeah.
here.
It should be a little bit more straightforward because there's a very clear goal, which is to be able
Yeah.
to play this game that everyone knows.
Yeah. Yeah. And then to be able to generalize it to future contributions.
Right.
So I haven't really looked. I've looked through this just a little bit, but do you want to just go through, sort of talk through it
Yeah.
quickly, and then we'll go from there?
Yeah. Totally. So here's the code base. It's a holochain app, so this is all standard stuff. None of this has been changed by me. I also haven't added any tests yet, which is probably just bad programming practice by me, but I'm not a good programmer yet, so there you go.
Uh-huh.
Um,
A lot of good programmers don't write tests.
um, okay, well, that's good to know, but
Yep.
I don't think I'm at a stage where I can claim to have made that choice
Sure. Sure.
intelligently.
Sure. Sure.
um, so yeah, again, this stuff all very pretty standard. I think I might have added. No, it doesn't look like. So the good stuff is in here. So here's our zone that's just called Rochambeau.
Okay. Yep.
And the idea here was, how can we break down the process of playing rock paper scissors, so that two people, it's sort of like you can imagine trying to play rock paper scissors with your friend over email or over text messages. Um, you can't simultaneously reveal your moves, right? There's
Right.
no way to do that. So how can you make sure that that you both choose your move, and then when you reveal it, you haven't changed your choice according to what the other person chose? In other words,
Yep.
how can you make sure the other person doesn't cheat? Um, and similar things like that. So I've tried to kind of break it down in a way that I think hopefully works for that.
Hmm.
And what I'm assuming is that a lot of that security has to come from the validation sections of the entries,
Yes.
because so my impression of how these zones will actually be used is that they're going to have some public facing functions, sort of like an API, and that's what your front end is going to be able to call those functions to make the game happen. Um, and those functions on the other end have to deal with the distributed hash table.
Yes.
And so if your validation is happening with those functions entirely, then I think it's a lot easier to screw around with it. You can create some fraudulent data and just submit that because you know that is going to fulfill whatever validation mechanism you need.
Right.
Whereas the validation that's on the entries, that's actually going to happen. Basically, what that says is it's not going to let you put something on to even your own hash table unless it can fulfill these
Right.
requirements.
Right.
And if we can come up with requirements that can't be gamed, then that should be pretty safe. Um,
Yeah. So my guess is that you're implementing a commit reveal scheme.
yes, yeah. So
Okay.
the basic idea of how would you play rock paper scissors over text message is, so before I send you whether I choose rock paper or scissors, and before you do the same for me, I need to send you a hash or a code that you can keep and use later, but you can't tell from it which move I've chosen.
Right.
But when I do reveal my move, you can confirm that hash is the same as that move.
Yes.
Um,
Yeah.
It's hard to
So
come
it's
up with a good metaphor for hashes because
right.
it's
I mean,
math and nothing else quite works like them.
right. They're one way. They're just one way functions. It's like, um, but once you've got hashes, you can commit. You can prove that you didn't change your mind
Right.
without
So
revealing what you chose.
right. So
So
we each choose a move, then we have to hash the move,
yep,
a gobbledygook
yep,
string basically. Then we send each other those strings. Then we can each reveal our moves whenever we want, and as long as you can confirm that the move gets hashed into
yep.
that hash, then nobody cheats.
Right. So once I get your commitment, your hash, I can send you the plain text of what I committed to, and you can send me. And once you get my commitment, you can send me the reveal of yours.
And
Um,
we don't have to worry about the timing of that.
right. As soon as
We
I get a
sent a totally
commitment from
different time.
you, I can just like make my move. And what you can do then is confirm that I didn't change my move after I saw yours, or whatever, because you can check the hash. You can check that the reveal material that I sent you hashes down into what I sent earlier.
Right. And so you can see with the entries, you can see that that is a basic part of the structure that I've set up here.
Yeah.
There's a move choice, and then there's something called a move choice hash,
Yeah.
where you're actually going to send the move choice hash first before you send the move.
Yeah.
It does, I think, in practice get a little more complicated because you have to do things like, well, if I send you that hash, how
And
can
there's
you
only
make
three options.
sure how can you make sure that I only send you just one hash? What if I just hash all three options and just send you those? You have to make sure that only you're counting only one of those as the one that I've committed to, right? Things
If you
like
send me
that.
all three,
Like I'll just
oh, I
choose
see.
on my hand rock, paper, and scissors, make
Yeah.
hashes of all of them, send them
Yeah.
all to you, and then I still get to make my choice later, unless you can prevent me from doing that somehow.
Well, if you send me all three, I'll go, which one are you committing to?
Right. So that's what I mean. Is you need to have a thing that says, no, 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 you have to commit to one of them.
Right. The first one I get is the one that I'm considering.
Right.
And if I get two, that's a breach of the protocol.
Right. And
Yeah.
I think you also have to do things like make sure that we're playing the same game. Like we've agreed that we're playing a game now, and it starts now, and you
Right.
can't use hashes that you submitted last week because we're using hash
Right.
tables here. So you might, it's not like a text message where I'm actually texting you the thing, like, and you see it, like physically. The
Yeah.
program would see it. So the
Yeah.
program
Yeah.
has to know to do. But anyway, so let's
Yeah.
start going through
I
it
think
before I
I think the
confuse
big
myself
the
anymore.
big the big complication is the reason that we have the nonce. The big complication is that like it's impossible to get to the plain text from a hash. But if you know there's only three options for them to have hashed in the first place, you can just hash all three things and then check,
Right. Yeah. Yeah.
and then see which one it is, and then you could know what they sent you.
Right.
Um, so what you have to do is mix it with enough
Salt.
random noise that they can't guess your noise, and then you can reveal that nonce and your choice. And if
Right.
those concatenated together match,
Right.
that just makes it impossible for someone to have hashed all of the options to check your move.
That's
It increases the option space to be large enough that checking them all is unfeasible.
so okay. So let's look at this stuff. Um, so these are the beginnings of the entries that we're going to have. Um, this is valid move is a part of your move choice.
Yeah.
This is the kind of thing we could end up using for components, right? Like
Yes.
this is where the component list
Yes.
somehow happens.
Right.
And that way you can make sure that components have to be part of this valid move, but then
Yeah.
any part of that can fill in this field in the move choice.
Mm-hmm. Mm-hmm.
So a move choice needs the name of the move you're choosing. It needs this salt, this random string that makes it sort of unique, so that they can't just hash and figure out what you chose. Um, and it needs some kind of address. I forget exactly what this is. We'll see what it is in a second.
Okay.
An address type is, this is the address of like an entry. Um, so this can't be an agent's address because that's a different type in holochain. But I think
Okay.
it can be any kind of entry. Um, oh, you know
And
what?
why does a move choice need an entry?
We're on the wrong. Why does a move choice need an entry?
I guess we'll see maybe.
Yes, we'll see.
Oh, I see. There's more here. Yeah.
Yeah, I just switched to the right branch.
Okay,
So
cool.
this is actually the right stuff. So we've got move choice hash first in this one. Yeah, and so it has a hash of part of. Yeah, okay. So this is a little different.
Yeah.
This is maybe not. Maybe we should actually start further down, because
Yeah. Okay.
I actually think this is actually the part where you can see most of
What's going
what
on?
I was trying to do.
Okay.
So the idea is that you're kind of making a chain again, even though holochain is itself a chain. So the
Yeah.
first thing we're going to do, and this is the part where I'm not sure exactly if this is the right way to do this or if there's another way. The first thing we
Okay.
do here is defining, basically starting the game, confirming that both players are starting this game. So you're committing something called a game ID entry. So it's just some kind of
Okay.
unique number that defines this game.
We are opening a game.
Right. And really the game ID is just the address of this entry.
Sure.
And it happens to include the addresses of the two people playing.
Of the two players. Yep. That makes some sense.
And the idea, I think, is that you would want somehow to have one single entry for this, or at least to have one single entry, so one address for the game ID, not two different game IDs for the two different agents. I'm not sure how easy
Right. So
that
that's
is to
like
do
the
on
seed of
holochain.
a hash chain to say a game is starting, we're playing Roshambo with each other. What follows from this are game moves and potentially a result. But they must be ordered. There must be a continuous ordering of these game moves.
Right, exactly. So the idea, luckily with Rochambeau, it's really simple, where a
Yeah.
game has two moves. Each player has a move, and you get a result. So that's pretty simple, which is nice. But yeah, so we're making this game ID first so that we can then point back to it with
Yep.
the entries that need part of that game. So
Yep.
sort of like a Genesis block of a block.
It is. Yeah.
So
It's
the
not
next
a block.
one,
But
right? It's just a Genesis
Genesis
entry.
it's the Genesis entry. Yes.
Yeah. So then the next one here, we've got move choice hash. So like we said, you actually want to commit the hashes before you commit the move choices.
Yep.
It's possible in the future there would be a way to commit your move choice, but not have it be viewable by anybody else. That holochain would have this way of committing something to your own local chain that's by definition not publicly available to anybody else using it. But I don't think that that functionality exists yet. At least I'm not planning on it here. So you would locally create your move choice, then you'd create this hash and commit this hash. And the validation for the hash has to include a game ID address.
Yep.
And so this validation is just making sure that there is a game ID at that address.
Mm-hmm.
We might want to do something else here. Something that I think we do need to do is confirm that there is no other move choice hash submitted by this player for this game.
Sure.
Haven't done that yet.
Yeah.
But something like that needs to happen, right? Like you need to make sure that only the first hash that someone sends is going to be accepted.
Yeah. Yep.
And that should be possible, but I didn't get to it. So next, once I've committed that, and actually this is totally independent for the players. Once I've committed my hash, then I can commit my move choice entry.
But you will want to wait until they commit a hash.
Yeah, you probably will want to if you want to win the game.
Yes.
But
if you don't wait until they commit the hash, then they can see your move and they can choose the one that beats it.
But I can prove I'm not cheating as long as I've submitted my hash before.
Yes.
I can
you
allow the
you
other
lose
person to cheat
you
by
lose
not
the
waiting for
ability to
them to get
validate
their
that they didn't
hash.
cheat, right? And actually thinking through this, only one person needs to commit.
Commit what?
Only the first person to commit needs to commit with a hash. The other player can then just like say rock.
Right, I guess that's true.
They don't have to then commit with a hash. The
Right,
second
they could
player
just
can
make
just
a choice.
reveal a thing.
Yeah, that's a
And
great
then
point. Yeah, that's very cool. I don't know how
yeah,
that's interesting. Yeah, no, we could totally do that.
yeah.
It's also interesting to make a program that both people are running the same program, but it asks them to do totally asymmetric
Hmm.
things. Pretty cool.
Right. It depends on right when you get there. Is there a commitment? If so,
Yeah,
just don't hash it.
right. Yeah,
Just
so
add
that
something.
probably does make sense to do. It's not what I did here.
Sure.
Um,
Yeah.
so find a move choice. A move choice has a bunch of info in it, actually. It has something called move info. This is the thing that's going to get hashed. So it
Uh-huh.
has the name of the move, it has a nonce, it has the two IDs of the agents playing the game. And then it also points back to the hash address that is the hash of this move.
Okay. My
Um,
guess is there's some redundant information in there, but
Probably so.
that's fine.
I'm
I
sure
think a
there's
lot
a
of that
bunch of stuff
information is
there.
going to be in the headers of the entries anyway.
I think if we figure out how to do that, it'll probably
Yeah,
make a lot of these validations a lot easier.
totally. Yep.
Um, and in fact, holochain may already be doing some of this validation work for us, and I'm just not sure exactly what it's doing. Um, but the validation that I've put here checks basically that the hash at the address provided in the move choice matches the hash of the move info. So
Mm-hmm.
you cannot submit a move choice unless there is a hash that correctly gets hashed from the move info in your
Mm-hmm.
move.
Mm-hmm. Mm-hmm.
Um,
That makes sense.
so that's this validation. Now at this point, we hopefully have move choices for both players, and we can do a game result. This is the one with the big mess that
Sure. Yeah, yeah, yeah.
I'm sure is really not a good way of doing it. But I'll describe what I was trying to do.
Sure.
A game result has two options. Since this is rocks, paper, scissors. It can be a win, so somebody could win, somebody could lose, or it can be a draw. I don't know if this is the best way to structure this. This is the way that I've done it here. So a game result is an enum that turns into a win or a draw. If it's a win, then it gets a winner address and a loser address,
Yep.
and it gets a field called game info that just includes the ad. This points back to the two moves. So it points back to the moves that those players submitted.
Right.
And then if it's a draw, they're not called winner and loser. It's players again, and again it points back to their moves. Um, so the validation that in my head seemed necessary at the time was, let's make sure that the player addresses, so the address of the winner, the address of the loser, match the addresses that submitted those moves. So we're gonna go check the. We're gonna follow those addresses, get the moves, check the authors of those moves, and make sure that
Mm.
that's the same player. Right? Make sure that the two players who submitted those moves are the two same players who started the game, something like that.
Sure.
And also, well, whatever, so something like that.
Yeah.
Second, we want to make sure that the game ID addresses of the info hashes of the moves match. So these two moves that we're linking back to, that we've included the addresses of,
Mhm.
let's make sure that those are for the same game.
Okay. Yep.
And actually, I think we're going 2 layers deep there. We're making sure that the game ID addresses of the hashes of the move hash. So we're going to follow, we're basically validating the whole chain here. We're taking the
Yeah.
addresses in the game result, we're following those back to the move choice, then we're
Yeah.
following the info hash address back to the hash, and then we're checking
Yeah.
that the game ID addresses are the
Yeah.
same.
Okay.
And then the third one is we're just double checking that those two moves do indeed resolve to the result that you're trying to are trying to submit.
Yeah.
So did that player actually win? Was it actually a draw? Let's just, that's
Yeah.
true. Again, probably not all of this is necessary. Also, the way this is written is for sure bad.
It looks very, very deeply nested,
It's
which,
really deeply nested. It's really deeply repetitive.
yeah. Yeah.
Because I'm bad at Rust.
So here's my guess about this. It seems like we're waiting until the end for a lot of the validation that we could be doing along the way. So like
Maybe, yeah.
if we were able to build up a proof of correctness as we played, by including the hash of the previous step in every current step, we could very easily prove that all of these things were in the right game, that the right players are the ones submitting it, and we could just at every step we could check the hash and check that the previous hash was in this hash, right? So my guess is that this can be simplified by including um, the previous step in every current step.
Yeah, I
In
mean,
every current step's validation, right?
yeah, looking at it now, it does basically look like we're building a little state channel on holochain,
Yeah,
game specific,
yeah,
sort of. And
yeah,
so probably makes sense to, for the most part, borrow the same technique instead of making something that's sort of specific to Rochambeau, which this sort of is.
sure.
There should be something that's just generally more like what you said.
Yeah. I mean, I think we start by doing it specifically with Rochambeau just as a prototype, so we don't have to think in the
Right. But like
general case.
the technique we should be using in this validation, what you're saying sounds more like what people have been using state channels and just blockchains
Yeah.
in
Right.
general, and
Right.
we should probably be
So
borrowing more
two
of
players come together and
full
create a
techniques.
seed of a game, and then the next step has to be that, you know, like a valid transition from a seed is a commitment from one or the other player. A valid transition from a commitment um, is a guess, is a maybe another commitment, or just a valid move, and then a valid transition from that is a reveal of the commitment, and then a valid transition from that is a game result. And
Right.
each one has an entry type, and there are validation rules about what the previous hash's entry type has to be, right? And each of those addresses, if the address of the previous entry is included in the current entry that somebody is trying to do, and we just make state rules about when a reveal is valid, when a commitment is valid, when a game result is valid.
Yeah, I mean,
And a
it
game result
does.
is only valid after a certain type.
Yeah, it does sound like we can. It sounds like we can just go look at how people have implemented state channels, or even just some blockchain examples. Um, I mean, it's
Yeah,
pretty different from blockchain, but
yeah.
the idea of how each block points back to the previous
But
block.
chaining, yeah,
Yeah,
yeah. Instead of blocks, it's a move chain.
yeah, it's a move chain. It's a
Yeah.
chain of steps that go into making the game.
But each move has rules about what move it can follow.
Yeah, and if the headers in holochain include things like when was this submitted, who submitted it,
I think it does.
which it probably does, then we can
Yeah.
probably do almost all of that with headers.
Yep.
You can check, did one, they're probably right. It's like, does this point back to? We do need to probably include the address of the thing it's pointing to as an actual uh, piece of the type,
Yes.
but
Yes.
most of the other stuff is probably in headers.
Yes.
So we can use
So like
that
previous game state would be the previous and the entry for the previous move.
Yeah, and I think this
And
loop that's an entire game for Rochambeau probably makes sense as sort of an atom in a lot of other games, right?
yeah,
Where two players do something and it changes the game state. So instead of
yeah,
a game result, it's really a a round result or just a
Yep.
result of the previous second of
Yep.
gameplay or whatever.
And we could extend Rochambeau to not have a draw as a valid state, but just have a draw mean okay, start again.
Right.
So a draw game result has the same rules as a seed.
Right. Right. Like once you have that atom of interaction, you can string it together very easily.
Yep.
So you could say, okay, instead of a draw triggering game ending, we're just going to trigger the loop again.
Yep.
That becomes the basic element of
Yep. Yep. Yep.
building
Yep.
building the game up. You can trigger that loop in all sorts of different directions
Yeah.
and numbers of times and with different components and
Yeah. So I think that's a big change that we can try to work on here.
right? Maybe
The other one,
a limited format for Roshambo.
yeah,
You have to draft components and then
yeah. Hey, that's actually a really
pretty cool
interesting
idea
idea.
actually.
Yeah. Um, I mean, at that point, yeah. Anyway, that's that's actually a really cool idea. Um, so I think the other thing is um, this does not accept arbitrary components.
Right. Yeah. So that I haven't dealt with that at all. I just
Right.
defined rock paper and scissors here and assumed you can make a way to
Right.
for that to be other things.
Right.
Then and then the other thing that's very specific to this is there's just a function
The right.
that allows
The
only rock paper and scissors and tells you what wins against what. Right.
right. Right.
It's
The
not
the
doing
determined
any of
winner
the
function.
stuff. Yeah, it's not doing
Yeah.
any of the stuff that we did in the proof of concept where
Right.
it's abstracted out the idea of like rules that go
Right.
with components, and there's a function that just takes whatever components and just takes their rules along with it, and then solves things correctly.
Right. Right. So we will have to extend this um extend this to accept arbitrary components and figure out arbitrary
Yeah.
winners.
Yeah, I don't think it'll be that hard to do either of those things, even with this
No.
current version, because we already have an example of how that works in the proof of
Yep.
concept, and we basically just need to plug those things in here
Yep.
and in whatever constructs this
Yep.
enum.
Right. And so the game seed will have to point to like what format we're in.
Yep.
And it'll have to retrieve the valid moves from that. Um,
Right.
but yeah, I think that'll be one of the easier things. Um, and so then like launching this game, I guess this is a Zome. So like what I guess maybe we'll learn more about this when we actually like spin up uh, spin up a conductor and start playing this. We'll like understand more what is going on and how another zone could start this game. I mean, maybe it needs
Right.
a function called start, right? Um, it might need a function called start that takes a mode and a format.
Yeah, I do think it'll need something like that, and it does seem like zones will be pretty easy to connect to each other. Like you'll
Hmm.
be able to have a um, holochain app that can you can click a button and it'll go download and start running stuff from
Yep.
another zone.
Yep. Yep. Yeah, for
That
sure.
seems really easy. So that'll be
I think
good.
I think I think the way that we'll plug into other games, like I'm trying to imagine like how would we turn like if Blizzard was like, oh, this is awesome, let's put Hearthstone on
Right.
set match games.
Yeah.
How would they not have to rewrite Hearthstone from scratch?
Right. So I think that of course, it would depend on how much you wanted to change the game. So,
Yes.
assuming, like, let's sort of leave the idea of the game elements where somebody wanted to say it's Hearthstone, except it's an open world RPG or whatever. Like, okay, you would have to rewrite it, right?
Yeah.
But but if you're using the same, interface,
Yeah.
then you should be able to grab components that are just grab a format that
Configuration.
maybe the format is a zone, but probably not. The format can just be an entry that's a list of other entries, right?
Yes. Yes. So I think what they would have to do, and really, they would have to rewrite their game to accept whatever set match games protocol of a format is.
Right. Yeah. I mean, I don't.
So
Formats are not even
that
really
would
a
be
thing in Hearthstone.
fairly minimal. But then they would just have to write a launcher for Hearthstone that accepted that a format and a mode, and then they would have to make their game return a result, a game result, I suppose. And if they can do that, then we can write a Zome that launches that program.
Yeah, I think so.
So I think we would just we'll need to write Zomes. We'll need to write like set match games launchers or like squad launchers that know how to launch a browser game, that know how to launch a native holochain Zome game, that know how to launch a Linux binary game, that know how to
Right.
launch those binary games.
But when you say launch, all you really mean is grabbing the right elements
Yes.
and then feeding them
Execute,
into your front end, essentially, right?
yeah. So execute the program um, with the right parameters.
Right.
Um, yeah.
Yeah, it does get. Yeah, games make this trickier, right?
Yes.
Because if you've got actual rules of the game that need to be elements, so they need to have markets, they need to be creatable, all that stuff. Um, then some piece of that needs to be, and I mean honestly, all of it kind of needs to be on a chain, needs to be immutable somewhere, and then it needs
Yeah.
to make a game that accepts that kind of element is much harder than one that accepts modes and
Yeah.
formats.
Asking Hearthstone to actually not use a Hearthstone server and
Right.
play peer to peer is different.
Yeah, or
But
like
I think we
grab a
should.
different set of rules that are
Yeah.
somewhere and then
Well,
use them somehow.
you just have a different level of detail that's on the chain, right? Like
Yeah.
if you're playing Hearthstone, you have to trust the Hearthstone servers. I mean, and like that's just something you signed up
Yeah.
for. And you're gonna trust the result that game, that program that you both ran and like connected to a central server, and you're playing this centralized game, um, and you're trusting that the game result that it spits out is valid. Like that's just something you have to trust. But I think it's nice. It'll be nice to have an option for a pure native game that actually does register every single move to the chain and everything's super validatable. But also, I think it's nice to be able to just like play Halo and have those results. Like as long as you trust Halo and everybody in, you know, playing this game kind of has to. Um, that's the way it works now. So we're not losing any trust
Right. Yeah.
by doing that. Yeah, I mean, but in that case, like Squad needs to know how to download the or know how to verify that the right executable is running. And there's like verified software stuff like check a hash of the binary or whatever.
And that's sort of what holochain is DNA.
Yes. Yeah. So it's like a forum. It's almost like just a foreign function interface, which Rust has good foreign function stuff. So we'll have Rust running other people's executables, like arbitrary executables, as long as those executables read formats in the way that Rust will hand it to them, or in the way that Squad will hand it to them. So we've got to come up with a protocol for that. A protocol for how Squad executes different kinds of games. Um,
Right. Um, well, like what? Give some examples of the kinds of games.
yeah, a web game. like a browser game.
Oh, right. That's a
Um,
better word. A web game is every game now.
yes, yeah, a browser game. Um, a native holochain zone game, I guess.
Right. So that by that you sort of mean like a game that would really be validating basically every step.
Yes, a game that is running like what we're doing with Roshambo would be a native holochain zone game. We don't necessarily the protocol won't require that it validates every step, but those games then do have the option to do that.
Right.
And then I mean I guess and just like an operating system native game, like a traditional style games, traditional native.
Yeah.
Yeah. Yep.
So we're talking about sort of having games that would be sort of completely serverless, um, but then also you could have games that have central servers for
Yep.
a lot of what they're doing still,
Yep.
but just sort of paste in some bits of this market system. So like
Yep.
Hearthstone, but they're using set match games to make custom cards that people can play.
Right.
But they're still
Right.
processing the game results. Like they're doing whatever else they want to do, just how they're
Right.
doing it.
Right.
It's like games that could use one type of element, or two or whatever, but
Right.
could just use one type of element from set match games and do the
Yeah.
rest of the stuff centrally.
Yeah, Hearthstone could even not accept new cards, but it could just accept new formats. So that
Right.
they have wild and standard now. Holochain could maybe be used to generate millions of
Yeah, modes and
just
formats
formats of
would
card
be
selections of the
great.
existing cards.
That would be, I think, a huge plus, because I think that those games suffer a lot from the
Yeah.
fact that
Yes.
basically the only way to play is as a spike.
Yeah.
If you're playing the ladder, you're either going to get oppressed into playing something very competitive,
Yeah.
or you learn to enjoy having, a 45% win rate or whatever. And both of those things are very hard if you're someone that wants to just build fun decks. What are you supposed to do? You just ask your friends to play all the time? It's the only
Yeah.
thing you can do? That's tough.
Yep. Yeah, I think this would be cool. I mean, the other sort of technically possible style here would be just the in-person game, right?
Right,
Like just none of it happens on a computer.
right.
The players go type in, say we're starting a game, and they walk off and play
So this
Rochambeau
is
together.
offline games, essentially.
Offline, yeah, sure.
Yeah, this is so some kind of manual
Manual entry of,
results.
and that's the one where the players just have to like, it's like, cool, I'm gonna trust you, and we're just gonna use set match games as a sort of record keeper for for us playing this like chess in person.
Right. Yeah.
And I think
Anyway,
actually that's more of a, I think that's more useful as a prototyping technique than anything else. Like I
right.
don't expect there to be any offline games that like actually matter much.
It would have
Uh,
to be some kind of game where it would have to be probably focused on modes in terms of its interaction with
yeah,
set match games, because I don't
yeah.
know how you would use elements that unless the elements were literal
I mean,
physical objects.
to be fair, a sports league like a live sports league would maybe work that way. Um, and there could be like the game result might require like a signature from everybody there watching live and the video evidence that it
Right.
happened this way and so on.
Right. Yeah, if you start, but that's sort of like now making it slightly online, sort of like
Hmm.
videoing the chess game and making
Yep.
entering the moves, and then it
Yeah.
can
Yeah. Yeah.
validate
Yeah.
the game.
Yep. Yep.
But yeah, if there are games where people really, really care about being on the leaderboard,
Yep.
this would let you make a leaderboard for anything you wanted.
Yep.
Global leaderboard for stickball or whatever sport you make up,
You would have to trust everybody's stickball entries, though. Like,
right. Well, if you had some kind of wanted to have some value.
yeah.
Right.
Cool.
Okay. Cool. Yeah, that makes a lot of sense.
So I think maybe what we can do from here is I can work on Squad and putting in this protocol. Oh yeah. And then how do we get a market into this too? Yeah, that's
right. So
that's the other
that's
thing.
a question too. Where does that
Right.
should
I actually think that's like I don't think there's a whole lot of design work for us to do on that, to be fair.
yeah, most of it should be already. The question is just what's the hookup, basically. I think.
Right, and there's the Web3 Rust library. I mean, Rust zones just need to go get stuff from Ethereum and pull that data in to use them.
Yeah, I think that the sensitive some of the sensitive parts will just be maybe for every element you have an entry in the holochain DHT, and then each of those entries is just linked to some Ethereum contracts, which are a bonded curve.
Yeah.
But then also you need a way to link agents, right? Agents running a holochain app to Ethereum.
For some things we might, and for some things we might not.
I'm just imagining it for
if you want to make it like if you want to make a game where only people who have invested in your game can play, then that game needs to
you need to log in to Ethereum as well, or something.
Or you need to sign some challenge from that game, but then that can be the game's business, right?
Yeah. It just needs to take in valid confirmation that you're the owner of some Ethereum address, and then it can go check.
Yep. And nothing in the set match games platform needs to do that for you.
Right.
What the set match games platform needs to do is create reliable markets for everything.
Yeah.
So like when you register your game, you need to get back some address that you can use to identify what curved bond is associated with yours with this game.
Right.
So I guess in that case, every element entry needs to create a curved bond and then store that enough information to identify that curved bond in the entry.
Right. Yeah, or vice versa.
What do you mean vice versa?
Would it also work to just have the curved bond point to the entry?
No. Well, technically, I think because games could then scan all curved bonds for themselves. But no, you want like if a game cares about its own curved bond, the game needs access to that information.
Oh, right. Like, yeah, that's true.
The address of its own bond, and potentially the address of all the bonds of the elements that it's being played with right now.
Right.
So like every element's sort of data package entry needs all of the relevant on-chain information, like a way to get to the relevant on-chain information.
Yeah, that makes sense. Yeah, I mean that seems doable.
Yep. And curve bonds are sort of a thing we can go research and do, right?
Yeah, I mean,
and that'll take, the big thing is going to be learning the Rust Web3 library, and Web3 libraries have never been good. I mean, they've been good, but they've never been easy to get into.
Yeah, I've had the thing that I've had trouble with most in the past is just they don't often seem designed for uh, people that like aren't already using something like MetaMask or Parity. You know,
Right.
they're expecting to just be sort of fed um, like a Web3 account.
Yeah. 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 Yeah.
And
Right.
there
Right.
aren't often easy ways of saying like I just want to look at what's going on, or I just want to generate a new one, or
Yeah.
something like that.
Or I want read only.
Right.
I just want
Yeah.
to read the chain.
Yeah.
Yeah.
Which is probably just me not being that familiar with it, but that's the part that seemed
Yeah.
pretty difficult to get at in the past. But yeah, it does seem somewhat clear what role it should actually play in all. And
Yeah.
tools that we can use to do that
Yep.
are built. Yeah. So what should we do now?
Um, let's see. You want to get into some of this, some of the Rochambeau stuff?
Yeah, I think either of these is a work on.
Yeah, let's try to figure out this holochain headers get entry stuff. I think
Cool.
that's a nice chunk.
Developer maybe.
So I found it here. HDK
It was what get entry.
HDK get entry. Yeah, I think so.
Um, I imagine it's somewhere in this.
You just search for get entry.
I think I'll just do that. Was it just get entry or what? I thought it was
Oh,
maybe.
HDK API get entry. Yeah.
Yeah, here we go. Get entry result. What are the difference between those two things?
Yeah, I
Retrieves the
don't.
latest version of an entry from the local chain. Retrieves an entry and its metadata from the local. I think that might be actually the thing.
I see. So yeah, actually, what did they? Yeah, yeah. So or Pythagorean showed us get entry results.
Ah, so this this does not tell us what this actually has in it or how to use it.
Let me see. Okay, so get entry result. So
It
it takes an
it gives
address.
us a get entry result.
It does give us a get entry result, and so it takes an address, it borrows an address, and it takes a get entry options.
Yeah, which we can look at. And I just want to
Right.
check before we do that if this is the same but does not take options. Yeah, right.
Yeah.
So this, yeah, okay. So it sounds like the options are for the metadata probably. So let's check those
Yes.
out. Um,
So the example that Pythagorean gave us was right. So the address and then get entry options, entry false, headers true. So we can just ask for the headers even.
yeah, so this is pretty simple. I don't know if there's more than this, but giving you the option for these four things. Status request.
Right.
I guess this is just whether or not there's an entry there, probably.
Whether or not to include the entry
Oh,
in the
or
get
that.
entry results.
Right, that makes sense too. Um, headers
Whether or not to include the headers.
and timeout. I'm not sure. I guess this is probably just how long do you want the timeout limit
How
to be,
long to
maybe?
wait? How long to wait before you give up?
Yeah. So see if it says anymore. Doesn't seem to tell us what's actually in the headers, but we could just try it and see what we get.
Yeah, what does the header, is there a headers type somewhere? Oh, no, no, no. So we want to, so
I
click
could search for it.
on, oh, wait a second.
Yes.
I don't know. I would try to, let's go back to get, so this is just a type that we're looking at. If we go back again to the get entry result, yeah. So let's look at get entry result.
Ah,
It's a get entry result type. Okay, let's look at that. So that's probably an enum. Yeah, so it's
yeah, it is.
either singular and all. Get entry result item. Let's see what a get entry result item is. That has a meta, which is maybe an
Headers.
entry, a chain header. Yeah, let's a vec. So that's a vector of chain headers,
Vector of chain head.
and a
Which
chain
actually is
header.
sort of interesting.
Yeah,
I wonder why it would have a. Okay,
because
yeah,
there's
let's
maybe more than one.
right in a. Yeah, okay. Construct fields a bit. Okay.
Yeah. Chain header of a source chain item. The
Oh, here we go.
addresses of the chain header used as items key. Yeah, so it needs an entry type, an entry address.
Looks like this is what's
Yeah,
an entry
a time
type. That makes sense. Entry address. That makes sense. Provenances.
provenances. So
This is
it's
some
a list
crazy
of
thing.
provenances. So that's
Yeah.
where it came from.
So this is what has signatures.
Yes. We gotta get down to provenances.
Oh, and that is in. That was in here somewhere. Yeah, look.
Yeah, yeah.
So that's okay. Maybe this is doing what we're.
Yeah, he's all of that stuff is like digging deep into that nested type
Yeah. So yeah, look.
and getting the
Provenances
first
first.
provenance,
Yeah, the first
and
provenance.
unwrapping it and cloning it.
This stuff is so still rusty.
It is. It is.
I look at that and I think like, wow, is that really the best way to do that? But there you go.
I think it comes out of the borrow rules.
Right. That's and the unwrap thing comes out of using like results and options for
Results,
everything.
yeah.
Um,
Yeah. That means this could plant panic if you use unwrap.
right. Yeah.
But that's fine.
Okay. So
Fine
we'll
for
definitely want
prototype.
to look at
We're
that.
still in prototype land.
What else this has? Oh, this is for links. Something we haven't
Right.
dealt with. But anyway, then a timestamp, which is this is the timestamp data type they use. I don't know what it is, but
ISO 8601, the
yeah.
standard the international standard.
Oh, is that what that is?
Yep.
International Standard Operation.
No, I don't know what that actually stands for, ISO, but
All right, so
International
provenance has an
Secretary.
address and a signature. It's a tuple of initiating agent and signature of some item being signed. Type is used headers, right? But I'm wondering why there are like a bunch of them.
That is a good question. I don't know why
And
there
then there
would
can
be an
also be more than
array of
one chain header in an entry because this came from a vector of chain headers.
Yeah. Probably some technical thing that we don't understand. That yeah, I wonder if the chain headers, I don't know. Well, we could take a look at it and see what's kind of in there when we get them. If we always see only one, then we know that there's something we don't quite understand.
Header has all.
That's my guess. Yeah, you want to can we go to the source to see what fields are emitted? Yeah, so it's entry type.
Yeah,
It's all of those things.
it
Yeah.
does have some more information though. Addresses of the agents that authored and signed this entry along with. Okay, so that sounds like it's just saying that possible for more than one agent to author
To
an entry.
author an entry. Okay. Cool.
Which I don't think we know how to do that, but I think we can
No.
assume that if we're creating functions that just have an agent create an entry, it's probably just going to put one address in.
Right. But
Or
that's an
one
interesting
provenance.
that's interesting to think. We may want multi-agent entries for like game results.
Right, or game starts too.
Game starts. Yep. Game starts. Game results.
Those sound like what we want.
If we're talking live sports, we might want like multi refs. We might want like a shelling game of observers. Um,
That's a cool idea.
to like validate the game. Yeah.
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 That must be a
You
thing
could be a,
people have suggested, shelling points for refereeing sports.
yeah, yeah,
You
yeah,
already
yeah.
have, if you're watching the Super Bowl, there's already 100,000 people in the crowd
Yep.
that are already there watching, and they
Yep.
have opinions.
They do. They do. What a wild that would change the game.
Yeah.
But if you start a sport with that in mind, that could be really cool.
Yeah, I mean that would be exciting. I don't know what would happen. It might be at least as fair as because it's a shelling point. It's not
It might be,
not
yeah.
just a boat.
You'd have to pay money to skew it to your team side.
Right. Yeah.
That would be the super oligarchy refereeing.
Well, you can make Super Bowl tickets cost quadratically
Yeah.
or whatever.
Right.
Like,
Yeah.
anyway.
Cool ideas. All right.
Right. Okay. So it seems like there's probably one provenance in the vector.
Prop for the ones that we're doing, probably, yeah.
Oh, look at that. Actually, here it's a vector. I think it was an
It's a vector.
array here.
Oh, that is interesting.
Probably one or the other. Whatever. It probably got
So it looks
changed at
like
some point.
So it looks like the function takes borrow of an array of provenances, but when it creates
It creates a
it,
vector.
it pushes all of those onto an array. Is my guess.
I don't have a good understanding of the differences, vectors and arrays in Rust, and what are.
I think the big one is that arrays can't change size.
Okay. Yeah, that seems.
Arrays have a fixed size. So when you allocate an array, you have to tell it exactly how big it's going to be, how many items are going to be in it, and that's a memory efficiency thing. It's less efficient. Like you can't optimize as much when you don't know how big the thing's going to be.
Right. Yeah. That seems like a big thing in memory management from what I've read. Like
Yes.
knowing the size of the thing
Yes.
you have is
Yes.
an important part about it.
Very.
Which
Cool.
has, I think, a lot to do with the borrowing.
Yep.
Okay, so that makes sense. So it's probably going to be one of these. Don't
Yep.
know why there would be multiple chain headers.
I don't either. But
Module contains definition of the chain header struct. The struct defines a local source chain in the sense that implements the pointers between hashes that the hash chain relies on. Checking data using chain header of a source chain item, the address of the chain item's key in the source chain hash table. I mean, that all sounds like there's one header.
it does. Chain headers are linked. Wait, can we go back? Chain headers are linked to the next header in chain and next header of same type in chain.
Right. So like if
Interesting.
how is it defining chains?
I'm not sure.
Because this is not a blockchain. It's not like there's just one chain. There can be.
Oh, but there's it's hash chains. They're using hash chains for validation. For like continuous validation over time.
Right.
They are holographic chains, not blockchains.
Okay. Well,
yeah, I think we'll get there.
yeah, I'd like to look at this again and see if we now understand what Pythagorean was saying.
Yeah.
At least a little bit more. So function
So the
get
handle,
agent,
I think, is an address.
The handle is. I looked at this a little bit. I don't know all of the ways he's using it here, but handle is a nickname that an agent can have, basically.
Oh, okay.
So an
Cool.
agent has an address, but they can also have a handle, which I don't know exactly what that's for, but it seems like it just makes it easier to deal with.
It's the sort of multi-identity login stuff we were talking about earlier, maybe.
Maybe so. Yeah, I don't know.
Yeah, interesting. Okay.
But it's taking a handle, or it's taking a thing that's going to call handle as a reference string, and this whole thing's going to give back an address, which is interesting because I thought that addresses weren't for agents, but maybe agent ID is a type that contains an address and also a handle.
My guess, yeah.
That would sort of make sense. Okay, so if handle exists for handle,
right?
So that's, or if it doesn't exist, same.
Yeah.
Then we're going to return this error.
Yep.
Handle not found. if get entry result type single, so that's how you get just a single item. I think we just looked at that.
We did. It's either single or all.
Right. If, what is result?
Yeah, what is result in that code?
It's not capital R result. It's
nope.
So it's not a result.
So this is probably pseudocode, and we can expect
yeah.
that is the yeah. So it's. Oh, I wonder if that's
entry result.
Oh, that's destructuring. Oh, wow. Okay. That's destructuring result is what I'm guessing. So in the same way that match works, we'll destructure and like bind names to things inside of types.
Oh, so let's look at this. Let's look at this again.
Yeah.
If I could find it again. Where was that? Somewhere back here.
I've been drinking a ton of water, and I need a quick restroom break, but I will be right back.
Okay, cool. Entry result type. Get entry result. Right. Get type single. As in get entry. That's what this result is. Get entry result item. At the address of this handle. With the option entry, we want the headers.
All right.
Okay, so I think what's going on here is result is this is a get entry result item.
Right, because it's the single. Yep.
So we're getting that out of.
Yep. Here. Oh, that's so cool. I love this destructuring stuff.
It is sort of magical.
Yeah, it like you don't have to dig. It just makes it so much less verbose.
Yeah.
You don't have to dig in there.
Right. So that's just whatever's inside here, which we're calling result.
Yeah.
So if let that thing equals the entry result at the address of this handle, which we're question marking, with these options. So we don't want the entry, we just want the headers. And I don't know what this default thing. Maybe it's some way of saying the rest of the options you should just use the default.
Yeah, I wonder if that's a Rust thing.
I don't know. We can
I
look
have
it
not
up.
come across it. Googling it. Ooh, yeah, looks like it's a Rust thing. A trait for giving a type a useful default value. Very cool. Sometimes you want to fall back. Yep. Drive default. Option, some options equals default.default. Yeah. That's what's going on. Okay, and then the dot. So there's two periods right in front of it. My guess is that's a spreader, spread operation. So it's like the rest of these, fill in the rest of these things with. Yeah.
Oh, so that's interesting. You can also use this to
that just means make foo 42, but the rest use default.
Yeah,
Very cool.
that's cool too. That's a cool syntax.
Very, very cool. Yeah.
Okay. Where were we? All right, we're looking at this. Right. Okay. So.
We're here to learn and rest.
Whoa. Where does this? Oh, that goes to here. Okay. Right. So we're saying, let's try to make a get entry result type single where the result is this.
Yep.
So we're trying, is this sort of a way of, wow, yeah, this is a crazy.
If let, well, let's look up if let. Because that seems like a specific Rust form.
Right, right, okay, yes, matching enum. That is sort of what it looks like.
Okay.
So if let sum I equal number, where number
some 7. I see. So then,
so that's not an enum.
Oh, if let maybe just is what you need to do to get the destructuring.
I think it's just a way of saying, like, if you just have this statement without the if,
yeah,
then it would give you it would resolve as an error or whatever kind of error if these enums weren't compatible.
Okay.
Something like that.
Okay.
Like, is it this is trying to set the result side of this as this.
Yeah.
Right?
So HDK get entry result returns a get entry result type, which might be single.
Right. Or I think what this really returns is actually a get entry result item. I'm guessing.
Well, right.
That's what goes inside here.
No. It returns a get entry result type.
Oh.
But then that is right. So get entry result type single, and then is destructured because what we want to pull out of the return of this get entry result is in there. Yeah. Is the get entry result item. So see in here, there's he's matching the return from that on the types leading down into result, and so pulling them off. It's like if he just said result equals hdk.getEntryResult, you would have a get entry result type, and it would either be a single or an all. And this, if it were a single, it would have a result inside. So this if let is saying, I only want to match on this one thing.
Just this.
Right. And that means I only want the result if it's a single type of that enum. So I think that
okay, right. So this is a way of checking that this is a get entry result type single.
Yes.
Gotcha.
Yes. It's a way of checking that this is the match that we're getting.
And then what is this?
Dot result. Yeah.
Is that a function being called? Like what? I don't know what that is at all.
I'm not totally
related
sure
to this.
myself. It may be.
It must be because he's using it again here. So I think this maybe also sets result as. I don't know why there's a dot here.
Yeah, I don't quite either. So there's the question mark at the end of that. So that means it's.
I think this is being called on this, right? Because there's no semicolon, and that's not a.
Oh, so yeah. Let's look at go look at the result type. Like what is inside a single.
Yeah.
I think what's
So it's
inside a
this
single
guy.
is a get entry result type item, and that has a result, right?
Doesn't look like it.
No, it has a meta, it has an entry, and it has headers. That may be a mistake.
Could be.
It may be meta that we want, or whatever. Like, we'll see.
Yeah.
We'll see when we get in there.
That would make sense though.
Yeah. So then what's in? So then basically
Right, so
what we're
he's
doing.
saying if
Result.
let this with
Dot result.
dot result, then let agent equal results, because we've also helpfully created this thing, and we're grabbing something out of the headers. Result headers, make an iterator, map the iterator.
Right, because there's this result is like, okay, so we want the headers, and there's multiple of them, and then
right. So then
each
header, we're going to take the first provenance,
right,
unwrap and clone, and then I don't know what that is.
0, and I don't know what that is.
Not 0. Oh, is that a way of calling the first item in an array? Is that what's going on there, maybe?
0th index, maybe. I think we'll learn it faster by playing with it.
Okay.
Than anything else. Presumably that's taking out the provenance.
I think, oh, you know what it's probably doing? It's taking the first item in the provenance.
Oh,
right?
Yeah.
So
which
is an address.
Provenance is a tuple, and .0 is the 0 part. Yeah, I do remember reading that.
Okay, so it's the address of the provenance.
Right. And then this .next, so map returns an iterator.
Yeah.
And .next just goes, all right, what's the next one? We're just going to unwrap the first one. Because it's a result. So we've got an iterator of headers.
Right.
We're mapping. Are you familiar with map?
Yes, at least in other languages.
Right. So it transforms the iterator into another iterator.
Right.
But with the result of this function called on everything. So what we're returning is we're like digging into the thing we want. And so that map is an iterator that has only the things we want in it. And we're just taking the next one, and then we're unwrapping that.
What does that mean, the next one? I thought map would have gone through all of them just in this one step.
Iterators have a method next, which gives you the next item out of the iterator.
But what is the next item in this case? First item?
It's the first. It's the clone. It's the 0th element of the cloned, of the unwrapped, of the first provenance in the header.
In the first header?
In the first header.
Yeah, that's what it is. Yeah. So it's like if you have an iter and you call next and you haven't done anything else yet, it's going to give you the first item in the iterator.
If we called next again, it would be the next provenance of the second header. Yeah.
Right. Yeah. Okay. Yeah. So this is a way of grabbing the first one of these. Yes. So it does look like we're looking for the address in the first provenance of the first header.
Yep. This is grabbing the address in the first element of the first provenance of the first header.
Yeah. My guess is a lot of the time there's one header with one provenance on an entry.
Yep.
But that it's possible for there to be more, and that's why there's all this stuff. Okay, so we got the next one, then we unwrap it because it's, I don't know, in a result
because
or something.
Next gives a result.
Yeah.
Next can be an error. If at the end of the iterator, if you call next at the end of an iterator, it's empty or like no more results error.
Right.
So you unwrap it because we're assuming that there's something there.
Right. And so this address is the agent's address. We've just set that address to agent. So if that worked, then we're returning a result.
Okay.
With the address.
Yep.
And that's our result.
That's our Zome API result of the agent. Yeah.
I didn't actually realize that you can don't need to do anything special for it to be a Zoom API result. You could just return a regular result. That works.
Well, right, because the type checker knows that whatever's in that spot has to be a Zoom API result, and OK is one of the
Options for
options
API.
for Zoom API result.
I see.
Yep. So it's a completely different OK than the result OK. It just happens to be implemented in a
right.
Standardized way.
Well, it's completely different in terms of like it's a completely different type, but
yep. Yeah.
Functioning this.
Rust doesn't care that it uses the same letters.
Right. Yeah. Else unimplemented.
Yeah.
Is that a real function?
I think it might be. It looks like it might be a real macro. Yeah.
Which I've not dug into at all.
Standardized
placeholder for marking unfinished code. Be useful if you're so example.
Yeah, it just panics. But it panics with a message that says unimplemented. Yeah.
Okay.
Yep.
Cool. Okay, so this is totally doing what I asked for.
Exactly what we want to do. Yep.
And I'm sure glad I asked, because it would have taken a while to figure that out.
Yeah, we would have been stuck on this.
We definitely probably would have not done most of this stuff. I mean, we probably would have figured out, but we probably would have not thought of as many things.
Yes. Well, we certainly wouldn't have learned about if-let, and we wouldn't have learned about that destructuring. Yep. This is pretty cool.
Cool stuff.
Yep.
Cool. Okay, so that makes sense. Yeah, I think what I was thinking I would have to do was use links between the entries. Like I was going to have to link.
Oh yeah, no, I think that's bad.
And I don't think we want to do that.
No,
I don't think we need to do that. I think the links really should just be addresses on the entries that point back to the previous entry.
Yes.
That's the type of link we actually want. Okay, so
we want the previous state's entry address as part of each state's entry address.
Right, exactly. Which is a kind of link, but it's not the kind of link that holochain calls a link, I don't think.
No, it's more of a hash chain than it is a link. Yeah.
Yeah, I think what yeah, actually, I don't really know what the difference is. A link on that. But there's some important reason given it.
Yeah.
That's not just okay if you want things to point to them.
If you just point to them, it's one-to-one.
Well, but you could include a.
I think it's a way to link elements after they've been created. So
right. Yeah.
So like later down the road, if we want to associate and then possibly have the possibility of disassociating them, like if we want the link to be flexible, we use links.
Yeah, it's like if you have a list and you want to be able to add things to the list later after you've already submitted.
Yep.
That's
or take things off the list, or like go back and forth or whatever. Here we need it to be absolutely every single time. It needs to reference exactly one, and it cannot change once it's done.
Yeah, totally. Cool. Okay, so I think we could definitely dig into this now. The first thing that I would do if I was on my own, I think, would be to just look up some background info on how people have done this with state channels. Just like what is the information that they're making sure to include in each entry as they're progressing.
I think that's a fine exercise. I think state channels are going to come with a lot of extra baggage that could get in the way.
Yeah,
of like really learning this quickly, but I think it's like a great excuse to learn about state channels. But
we could just start trying to write things down.
Yeah.
Which I'm also down to do.
And we're not streaming your editor right now.
Yeah, so let me make sure that I have that. There's a way for me to check that this is working without. Oh, what? Is that called? Yes, good.
Oh, there is a transition mode or a studio mode that you can like set up your next view
Yeah.
in the old OSB.
Now here we are. Old mess.
Awesome. Yep. All right. So I think this is there's a uh big job here.
Yes.
Um
Yeah, we're talking about basically redoing it.
yeah. So the strategy we have is that each entry is like a state in the state machine of the game, right? So so the first state is a like I don't know, maybe a proposed game with player state or something, and that's the
Right.
start game with player.
Well, and also before we get there, it's like the idea is that each entry kind of fully validates the previous one.
Yes, and the validation for each different entry type checks that the previous entry is a valid previous entry for this type. Like you can't reveal on top of a seed a game start. You need to reveal on top of a commitment.
Right. Yes, right. Fully validates. It's sort of fully validates itself using the previous.
Yeah.
More accurate.
Yeah.
The idea being that that way we don't want to have to do any more validation later on. Like
Right.
we want each step to kind of validate itself, and then
Right. And then the
nothing needs to.
validation function and everybody else in the chain, if I try to push out an invalid one, um, everybody like first of all, won't be using that DNA. I would have to be like faking it somehow.
Right. Yeah.
But then also everyone else would try to validate it and go, oh, that's not, it wouldn't validate because it didn't follow the correct move or it didn't follow the correct type.
Right. When putting it into their hash table and whatnot.
So to start building something like this, I would start by just thinking through mentally, thinking through like how would we describe it if we were just playing, like writing a rule book or whatever for a manual game. The sort of only always valid move is start a game. Yeah. And in order to start a game, you need to know two players.
Yeah. So
right.
Should be basically, yeah. I don't think that there's anything else you need there because holochain is going to make sure that they're using the same DNA. So
Yep.
It does
Holochain's
that for
going to
us.
handle a lot of this for us. Yeah. The only valid move on top of start a game is to commit to a move.
Okay, commit to a move. This
and
means
we might want to specify who has to like the protocol. It might be nice for the protocol to like be explicit about who is supposed to commit. Like, does the person who started the game do they also commit to the move, or I think actually the person who has been, the so one person starts a game and they reference someone else. That someone else accepts playing the game by committing to a move.
Right.
Seems like a nice way to do it. So right, start a game just doesn't need to identify two players. It only needs to identify an opponent.
Right. Okay. By opponent, then
the only valid move after the start of the game is for the opponent identified to commit a move. Yep.
Move. This kind of implicitly confirms that the game is happening.
Yep. Right. It implicitly accepts the game. The first is like an offer of a game.
Yeah.
Yeah.
But I don't think that doesn't need to be formal at all because
I don't think so.
You can have people creating start game entries that just don't ever progress, and they'll never turn into game results, and not a problem.
And they can rage in their homes, and it won't bother anybody. Yep.
Quick, it's a move, and this is kind of hash.
Yep. Yeah. So that's the hash of the move and the nonce and maybe some other stuff, but
It's hash. It's
yeah.
functions as a hash. It needs to be not reversible, even
Right.
by brute force.
And then the only valid
there's
move,
only 3 options.
right? The only valid move on a commit is a move, like a plain text move.
Move. Hash here.
Yeah.
Then opponent reveals committing.
The opponent, we could even skip the reveal step and just the opponent registers a game result or a round result. Either a round result or a game result.
Right, which includes their move.
Which includes their reveals, yeah.
Yeah, I mean...
Yeah. So an opponent revealing the move and figuring out whether or not somebody's won can happen all in one step.
Right, so you could say that the game result, and the game result includes something that we could call like the final move or something like that.
Yep, final move. Yeah.
Because it's just sounded weird to have it be like the game result includes a move from one random player. It's like that seems weird, but it makes sense if you think about it as like whoever makes the final move.
Final move can also claim checkmate. It's like saying checkmate when you make the final move in chess. Yeah. But there's another valid entry after player commits a move. Opponent commits a round draw.
You mean another possibility?
Another possibility is that the opponent commits because that won't be a game result yet, right?
Oh, well, I guess I was assuming that it would be for now.
Yeah. No, that makes sense. Yeah, that's the simpler protocol is that.
Because I think it's easier if you say, okay, if once we have that, then we can change the rules so that actually if you get a draw, it instead starts another game.
Right. A draw is treated as a start a game.
Yeah, okay, so this is many fewer steps. Now we're starting a game, which really just identifying an opponent.
Yep.
And this is like an entry that has an address.
Yes. An entry that has an address, an author, a timestamp.
Right. And it sounds like, actually, I don't know about the timestamp, but for sure the headers of entries include authors.
Yes.
You know that. I'm not sure they include timestamps.
I thought I heard someone on some video say that, but they might have been saying that about the old version and not positive. My guess is that it does. CRUD status.
I don't know what that means.
Create, read, update, delete status. Live, rejected, deleted, modified, locked.
Okay, so that's
kind of cool.
Perhaps in here. Get there before?
I don't know. Oh, yeah. Get result item. Headers.
And it had these.
Timestamp. Yeah, it needs a timestamp.
It does have a timestamp.
Yeah.
Okay, cool.
Maybe there's a default timestamp of like January 1st, 1970, but.
Right, yeah, I guess we don't know. I mean, my guess would be it automatically gets the timestamp because.
That holochain handles that for us.
Yeah, because when in all the example entry definitions, you're not having to.
No, and we're not calling this chain header new. That the conductor is calling this.
My guess is it'll do this. Anyway, okay, so right, so it's gonna have an entry and it's gonna have all the header information that all of them will have. Then the opponent can commit. Has to be this person with the address. So maybe we can start taking notes on validation. For this one, there's no validation for that. Well, actually,
the validation needs to be that the
maybe-
opponent is an address.
right.
Oh, yeah.
Opponent
Needs to be a valid address. Yeah, opponent 6.
Which I guess in this, I actually don't know what that means exactly when it comes to agents. Like, if I'm an agent, does my address only exist when I'm currently running a computer?
That's fair. Yeah, it's not.
I don't
That's
actually
not.
know.
I guess we'll get there. If we could validate that, we should.
Yeah.
And we'll figure that out when we get there.
Then this has to confirm that that this opponent or the header address. The opponent has to be the same opponent.
Yeah, opponent has to be the opponent identified. Yes.
Opponent.
And so part of the commit move entry needs an address of an identify an opponent entry.
Right.
So
yeah, address of. We'll just number these.
Yeah. Address of a 1. Yep. And that the opponent.
And actually, this isn't validation. It includes, has to include.
Yeah, sure. Address of 1.
And then the validation is that it confirms that the address of this one is this address, or is the address of the opponent at that address. Sorry.
Right. The opponent identified in entry number 1 is the creator of the number 2.
Yes. Yeah, which we can validate as long as we have this address.
Yes.
And other people
because
can
we have
validate
the address of that entry. Yep.
And anyone can validate it. Important.
Yep.
Okay. So should be all we need for this one. Next one.
We can also identify that the hash is the right length.
Yeah, I guess that's true. I think we should be able to do that with just typing. Like we can have a type that's the hash.
Oh yeah, I see.
And then
not typing on a keyboard. Yeah.
Just typing is a powerful thing.
Yes.
I don't know what to tell you.
Yes. Right. Let the type checker validate that for us. Yeah, sure.
Player. Okay, so the first player 1. I don't know, whatever. Whatever.
Right. So now,
it's a move, which presumably is going to somehow include address of number.
Yes. Every single entry will include an address of the previous entry. Yes. Of the previous game move.
It doesn't really need much validation other than that, as long as, again, the typing should be able to make sure that it's a valid move for the game.
That might actually be pretty difficult once we get into arbitrary future valid moves.
What do you mean?
We may have to validate that, like, the string is in a list of, like, whatever format. We might need to validate that the move is in the format.
I think we would need to validate that. Well, I think that we can probably do. That's actually probably the easy part, right? Because you can load up the format just at the beginning of a game, and then you can just check if it's in the list, essentially. And you can even do that with typing with an enum and things like that.
Right.
But
imagine somebody has written their very own lying Rust client.
Yes. Well, but
with
a lot of
types
this
that
stuff is in the
break
DNA.
stuff. Well, okay, so they can lie about what their hash is. They can lie about what DNA they're running. So someone could write their own lying conductor that lies on their behalf.
That's true. Yeah, they could
Right.
they could write a lying conductor
Right. So
that says that they're running the right DNA when they're
what they
not
can't
running
do
the
is
right DNA.
fake a hash.
Right.
So we do want to validate here that at each step that you know the move is in the format. So we could just say validate move is in the format.
Right. I mean, we kind of, yeah. I guess we don't need to do this here because we're gonna do it here for the other move.
We can't validate it with the hash.
Yeah, we would have to.
It's impossible.
Yeah, it is.
But what we can do is validate once it's revealed whether or not it's in the hash or it's in the format.
Yeah. The other thing I was thinking of was like,
yeah, move it.
In most games, you don't just get a list of moves that you use anytime, right?
Yeah.
There are conditions beyond is it just in the list of the format of whether or not it's a valid move.
Yeah. Right.
And that will be a little bit tricky to include in this validation too. You'll have to, in some cases, run through all the previous rounds of moves in the game through the rules of the game to give you a list of what the valid moves are.
Yep. And in that case, each move could include a ton of metadata about the path that got it there, so that you don't have to go tracing back through a ton of stuff. But yeah, that'll definitely have to happen.
Yeah, and I think that's the kind of thing that will vary game to game quite a lot.
Yep,
of course,
for sure.
This game, that's not necessary at all. In some games, you might be able to figure out a very efficient way of doing that without having to replay the entire game on every move.
Yep.
And then there might be games where you really do need to replay most of the game or a large chunk of the game.
Yeah, I think in just about any game there will be serious efficiency ways to be efficient by maintaining lots of metadata and keeping it around. You trade space for speed. Yeah, I think that's all. So okay, so player commits a move. We need to validate that the move is in the format, and we also on 3 we also have to validate that the player is the original player. Like, because some observer could theoretically commit a move and identify this game, identify the previous hash and identify the game,
right?
Not be the right player.
So there's two ways to do that, right? One is to put that information in somewhere.
Yep.
Or to have this validation trace back the whole chain, which is not very much in this case, but in general, it's like, is that a good thing to do in the validation to go back through?
Let's keep pulling the information forward, just to like as a technique that we expect will be useful for other games.
Yeah.
So it includes the address of number 1 and the address of the player of number 1. And validate that the opponent is the identified opponent and that the number 1's author is the number 1's author.
Format and author.
Yes. Yes.
Okay. Yeah, I mean, this is the kind of thing that I think was leaked to include this, what looks like unnecessary information.
Yeah. That makes sense.
Yeah.
Yep.
But yeah, it makes sense. Hopefully that won't get too bulky as we go. Of course, nothing's really going to be bulky in this. So
nothing's going to be bulky at all. Yeah.
We're thinking in the future, and we don't really know. But Yeah. Okay, so for the last one, the opponent commits a game result. We need to include the address of number 3. We need to confirm that this is the same person, number 2.
Yes. So number 2 should probably include
Yeah.
the address of both players.
Well, so it includes its own
One's
author
and
address by default, and then it can include this.
Yeah.
And the author of this has to be the author of this in order
Right.
for this to be
Yeah.
or for this to be put in the chain.
Yeah.
So then this one needs to include the address of number 3. I'm just going to assume it probably needs to include the author of.
Well, I don't think it does. I think because now nothing depends on it.
Except for its own validation.
Address of number 3's author.
Maybe we won't need it.
We would have to validate that anyway by checking number 3's author, and we know that number 3's author is valid. You know what I mean? Like, the opponent could put any address in that address of number 3's author spot. And we'd still have to check number 3's author to validate it. So the only reason we're putting address of number 2's author in number 3 is so that number 4 doesn't have to go down the chain all the way to number 2.
Oh, right. Okay.
No number 5.
We already did this.
Yeah. Right. So it needs to include the address of number 3. It also needs to include the reveal of number 2's hash.
Right. Yeah. I mean, we've been kind of assuming like that this will include a move, this will include a hash. We didn't write that in include. But yeah, so it will need to validate that.
But we're not saying anything about a reveal here or a move in a game result. So sure. Yeah, no, but it's implicit. That's fine. Final move hashes to number 2. Yep. To number 2's commit.
Yeah.
Commitment. Yeah. We also need to validate that the result follows the rules of the game.
Follows rules.
Yeah.
Right, which is similar. Like we need to kind of do that here too, although
we can't.
There isn't.
Do it there.
Yeah, there's no reason to do this in this game because there's no rules here. Like the rules are you can pick any of these moves and it doesn't matter what the state is.
Right.
But there are games where you would need to do a similar thing here, like move is valid at this game state.
Yeah.
We won't now, but it's basically the same step as this step. It's just not the game isn't finished, but you're running what's happened through.
Right, like that would check like player doesn't have protection from the color you're trying to play.
Exactly. Yeah. At this moment.
Yeah.
And this would do that same thing, except the assumption is that if it's all correct, then the game also ends, which it also checks.
Right. Yep. Right. The result is the correct result of the game.
Right.
According to the 2 moves. Yep. It might even be nice, since this is so simple, to actually like not only include the address of the previous entry, but all of the content of the previous entry. I don't know. That might be a little redundant.
I'm not sure. Yeah.
Anyway, because this validation if you do has to look up 3 and then get the address and then look up 2.
Right.
unless three also includes the hash that was committed in 2.
Right. Hash from.
Ooh, no, that would go in 3. 3
right,
would
right.
keep the hash from 2.
Oh, I see.
Which is starting to be almost all of the previous data, but I think that's fine. I think having the hash from 2, like previous moves, having all of the information that the current move needs to be valid, to know if it's valid, is a nice design goal.
Right. I mean, it's again that same question of like, is it better to make each of the commits bigger, or to have to look back multiple steps?
I think
Either way, in longer, more complicated games, both of those are gonna get big.
Yeah.
The question is, which is it worse to get?
So that's a research topic, I think.
Yeah.
But in general, it's usually better to, when you start to scale, it's better. It's usually worth it to trade space for speed. Now, space in this case with the distributed hash table will have, because we've got to send stuff around. So the more data we have, the more network traffic we have.
Yeah.
And so that's a question of like where that balance is. But I think choosing one design philosophy right now to get some experience with, of like saving, like preferring trading memory for speed, is a good place to start.
So we actually need to do a little more validation here, I think.
Okay.
Don't we need to validate that this address is actually the address of number 1, number 1's author?
Opponent is the identified opponent. Yes. Yes, we do.
Validate
Yes.
that, and we need to do the same thing here.
Yep.
With both the address and the hash.
Yes. Right. Yep.
And then this one doesn't need any of this extra stuff because this extra stuff is here, so that further steps can check back on them. And
right.
Last step.
And no further step is going to check back on this.
This is the final countdown.
So it just needs to look at.
Just needs to link back to number 3.
Yeah. So that players that want to validate,
in order to validate itself,
know where to go. Yep.
Yeah, it's like the validation needs to look at the previous entry, basically. And in order to look at the previous entry, you need to include the address, because you can't also submit the previous, or
right.
You only get what you submit here to the validation. So we need this address in order to look back at the previous.
Right.
Stuff is here.
And this enforces an ordering.
What enforces it?
The fact that each subsequent move needs the address of the previous one.
Yes. Yeah, and also just the way we've set this up solves the problem of, it's a symmetrical game, so how do you both decide to start the game? Like, well, you don't. One person decides and one person accepts.
Yep.
Cool. Of course, that still does leave a question. Like, if I click the find match button in a client, how does that make it happen between two people?
So I think what you do is you broadcast the willingness to. You broadcast your intent to accept any game that somebody proposes for you.
Right.
And then someone else who like sees your broadcast and says, I'll play with you, then they start the game.
Yeah, I think ultimately it doesn't really matter, and that there are a lot of ways for the client to decide who should be asking and who should be accepting. It could decide according to connection quality and whatever,
Sure.
Could be just arbitrary.
Friend lists. Yep.
Well, I mean, like if you click the button and everybody else is clicking the button, and what the button does is offer to accept a game, then who's proposing games, right?
Yeah.
Somebody asks you.
Yeah, and that's all in the client. The client can handle all of that.
And it doesn't really matter the way the client does it, or in terms of creating valid games. It does matter in terms of the quality of your experience, but
Yes.
clients can figure out the best.
And our presumption is that that quality of experience will change how much investment in that game clients uh, uh, curve bond. Yeah, the level of investment in that curve bond. Anyway.
Yeah, and for sure, clients and tools are the trickiest things. How that's actually going to work in terms of the investment. It's much easier to imagine how that would work with components or formats or modes.
Totally.
But it should work with clients and
it should
game rules as well.
Yep. Okay. I think we can start.
Yeah, so I feel like we can do this.
Start building 1, 2, 3, 4. I think those are each entry types.
Yeah. So we need.
Yeah, I would actually start just breaking this up. Oh, sure. Yeah, that's
entry definitions.
Sure. Yep.
Those are the big ones for now, I think. And then we need like just these functions, but these functions are generally the easy part.
Yeah, no, totally.
Commit it. Most of the work is really in the validation of the entry definition.
Yeah, for sure. Yep.
So once you have these things nailed down, the rest of it should be basically very bare bones stuff. And then also the rules, which will be a conversation too, but the rules are very simple.
Yep.
Actually writing them is hard.
So let's go through each one and see what types are implied. Identify an opponent.
So a bunch of these types exist already in holochain, like addresses. That's a type in.
Yeah.
Hash. But I think holochain does have hash string.
Okay, great.
What I found was an example of somebody using just this multi-hash 256.
Yep.
Which is not a holochain thing, but it seems to accept this as a way of making a hash string.
Great.
And holochain does have this way of doing that. So a lot of that hashing is also in holochain. So we don't need to make our own hash type.
That's good. What we do want to do is type the players.
Right, into like
a player one type
starter and starter and opponent or just player one and player two. We could say, that doesn't communicate the idea that one of them is proposing the game and the other one is accepting it. But if there's not a good way to say player one and player two is.
Yes. I mean, challenger boxing has this too, right? Like
challenger and
or like player and challenger.
Yeah. Host and challenger or something like that?
Sure. I mean, I think it doesn't matter a ton what we choose, but because it's only going to be valid for this game, right? For Roshambo.
Yeah. Now, are you thinking it would be something like this? Yeah, something like this.
Sure. You got a double Y, and I can actually just fix that, can't I?
Yes, you can.
Hey, that's great.
Host and then these probably need addresses in them.
Yes.
So holochain, actually, maybe we should look this up quickly. Holochain does have this type called an agent ID.
Okay.
Which I assume just includes an address and also some other stuff, but maybe we can look at that and see if we think we want that or we just want the address.
Yeah, let's quickly look at that. It might not be worth spending a ton of time on, but
I think it should be pretty quick.
Yeah. It would be nice to get that cleared. I mean, if agent ID basically restricts, like guarantees to us that it is an agent and not the address of an agent and not something else.
Right, and not an entry, an app entry.
So this has a nickname too.
Right, this is that, or I guess this is not the same thing as handle, but seems similar. Anyway, but yeah, so it has maybe this is what I was thinking of.
And a pub sign key. Yeah.
Yeah, so I don't know what this is the agent set their own nickname, and then this is their
Probably.
public key.
Yeah, the key is the public. Its key is the public signing key, and is also used as its address. So yeah, agent. Yeah, let's try that. If we run into problems, we can change it back to address. But I think that might be nice for what we want.
Yeah, I was using agent ID, but I didn't really look into it.
Yeah. Yeah.
Okay, so these are our two players. It's really going to be helpful with this structure to have them have different names since they've got sort of clearly roles.
Yes. Yes.
So now we have names that we can call them.
Yep.
Fine,
We can differentiate them. Yep.
All right. So what else are we going to need? We've got addresses are a thing. We've got players. Hashes are a thing already. We are going to need some types for basically each entry, I think. Like we'll want
don't we get that?
Want like a game start, type of thing.
Oh, I see. Right. How does that work? I feel like 2 weeks away from holochain, and I don't.
Well, yeah. So check it out. When you're defining an entry, it wants your entry to have a native type.
I see. Yeah, for sure.
So we
yeah.
just
want a
want
type for each.
anything that has an entry, want a type that defines that.
Yeah.
So game start.
Maybe you call that a game offer or something, or a
Yeah, sure. That's better than game start. Game off, and so that's going to have the host address.
Yep. And it's going to have a challenger.
Oh, right. So yeah, actually, sorry, I meant challenger. But the host is just gonna be the address that's in the header.
Yes, right.
Don't need that.
It might be convenient.
It could be, but well, let's see. So
no, thinking it through, maybe
I don't think so. So it's convenient in that I don't think it's convenient because if
you have to check it anyway.
Yeah, we would have to check it here.
No matter what.
In order to not check it here. So yeah, we're checking it either way.
Yeah.
For sure, this will eventually need more information, but because there's only one game and one set of rules and one, all that stuff.
Yeah.
Then the only thing that's changing here is who you're challenging.
Yeah. Oh, maybe this is called a challenge.
Oh, yeah, that's good. And then the next one can be called like a well, it could be acceptance or it could be like a first move. Both things.
I think you call it a commitment. So the way this works is you go.
That can mean both things, so it's nice.
Yeah, right. So a host makes a challenge. The challenger makes a commitment. The host makes a move. The challenger commits a game result, and that's always what it is. Challenge, commitment, move, result. Struck do.
Right. Okay. So for the commitment, we need a hash string of, we'll call it the move hash. I think that's
Yep.
Should just be able to use the type that holochain has here. But we also need the address of a challenge.
Yep.
which if we wanted, we could even make a custom type for this, but we probably don't. And it also needs a host.
Yep.
Realize this still says host.
Oh, yeah. Challenger.
Oh, actually, this is a little wonky now because we're sending a challenge to the challenger.
We are challenging a challenger.
Yeah.
Oh, yeah.
Which is not usually how it works. I mean, maybe it's just fine. Not like boxing, but it's
no. I think you're right. I think we should take the time now to think of that, because that could get confusing, and it's good. It's good programming to avoid those sort of technical changes. So I mean, maybe it's
just an offer.
Maybe it's a hosting.
A hosting.
No, that's yeah. I mean, maybe it's just a game.
Sure.
Maybe
I would say like
Roshambo
game offer or something. I don't know.
Yeah. That actually makes more cleaner sense. Yeah.
Oh, do you put commas here or not?
I do, and the reason I do is because of diffs in. So you want, if you add another one, if we add another one to the bottom of it, and then we have to add a comma on the previous line. The previous line then shows up as a change in the diff when nothing really actually changed there.
Interesting. That's a very specific reason.
It is a very specific reason. Yep.
Another random specific question. I know that there's some kind of thing going on with people using tabs here, 4 spaces, 2 spaces. Yeah. I read in the Rust book that they use 4 spaces.
Right.
Why does that matter?
Well, it's really important that everybody does it the same, and that you don't have a mix in your file.
Why is it so important?
When you have a mix in your file, depending on how your editor is set up and how it interprets a tab, you could get your indentations different, right? If your tab is set up to 8 spaces and you've got a mix of 4 spaces and tabs, your indentation, you can't tell what the indentation actually is, like what's indented to the same level. So it's really important to have them the same. I kind of don't care one way or another, as long as everything in a file is the same. And what that means is that, especially if you're working with different people and a community, a language should set a standard and everybody should just follow it.
Cool. So when I'm typing in this editor, I should put 4 spaces, not tab.
When you hit the tab button, your editor knows it's Rust and knows Rust standard and probably puts in 4 spaces.
Okay, even though from my perspective it looks like a tab character.
Yeah. Oh, that's a bummer. Emacs puts in the spaces correctly.
It's just a tab.
That's lame.
Okay. Well, anyway.
Yeah, you can probably set it up to do it right.
Maybe so.
But yeah,
not gonna worry about it right now.
Yeah, don't worry about it right now. But when a project, and again, in a prototype, it actually doesn't matter that much. It starts to matter when a lot of people are working on it over time.
Okay, well that makes sense. All right, so let's check. So the commitment, that's spelled right, right? Not two. Yeah, it's 1 T. Needs the hash of the heat.
Yep.
It needs the address of game offer. Just call it offer.
Sure.
Aesthetically, I'm wanting now to have everything not have the word
player offer, commitment, move, result. Yeah, that's nice.
Yeah, so the address of the offer and the address of the offer's author, which is called the host.
Yeah.
Who is called the host.
Yes.
And actually, it's an agent ID, not an address.
Right. And then what are we going to do? We're going to validate that the opponent is the identified opponent. Do we have enough to do that? The opponent.
Yeah, so that means we need to check that the address inside of here is. No. That means we need to check that the address of this.
Yes.
Of the person who authors this
commitment
is this. That's what
is the challenger in the offer.
Yep.
Right.
Yeah. And then we're also
address of game offer address. Yeah.
Yeah. Well, then we're also validating that.
Let's change that to offer address. I got it.
Oh right. Yeah. Sure.
Yes, I think we have enough there.
I'm gonna down here, even though we have it up there.
Yeah.
Now we have the right words. So we're validating that offer address is the same as player host address, or I don't know if that's the right syntax.
No, the offer address is an entry address. We need to
I guess the offer address offer
is the host. Yes.
And then also that commitment offer is the challenger.
Is the offer address dot challenger. The challenger in the offer.
Challenge offer. No, this is right. Yeah, the author of the commitment should be the challenger from the offer.
Right. So, and I would notate that in this pseudocode as offer address dot challenger, or
offer.
Yeah.
Okay.
Yeah. The challenger that is found in the offer address.
Okay.
And the host is the right.
Host in this.
Host is the ID that we're putting in there. Yeah. The commitment offer. Yeah. Yep. I think that's the validation we need to do. Yeah.
Host and commitment offer challenger.
Yep.
That's
cool.
Nice. That's nice and.
That is very nice.
Okay. Cool. All right. So for a move, this needs to include a move. Now this is probably a custom type of some kind. What a move is.
Yes.
Probably. I mean, this is sort of what I had before.
Like this, yeah. So we want to think about this because enums aren't dynamic.
Right. You cannot add more options to an enum, but. Yeah, so really what this really is format. Because that's something that would get statically created at the beginning when you launch a game.
Yes.
And you can make one.
So and a format has a vector of either a vector or an array. I guess it can be an array. Of moves, yes. And a move is maybe just a move. No, a move is a string. So let's if we think back to the JavaScript prototype we did.
Yeah.
A move is a name and some rules.
Yes. And they're both just strings.
They
are. Is that the best way to write a string in Rust? Do you just write string?
Yep.
I still don't know that.
Yeah. That is a built-in type.
Yeah, because you can do that too, which is a different thing. You can do this crazy thing. There's just all this crazy.
Yeah. Oh yeah. There's a lot. There's a lot, and I still feel like I'm in over my head.
Yeah, I got so many errors with the just like trying to return results that like the error part of the result and what the type that should be that you need to put in the definition of the function, like all sorts of crazy stuff like that. man.
Okay. So I remember now. I remember now how what the move, quote unquote move is.
Mhm.
And we might want to call it component.
Right. That's probably yeah. And honestly, like this is stuff that would probably get. We'd probably just make it crate for this stuff.
Well, the components are different shapes for different games.
That's true, I guess. But
So
I imagine some might end up.
yeah, something like default JSON, honestly, is probably what we're going to end up using here.
Right.
Because so a component here, what we did in the JavaScript proof of concept
Mm-hmm.
is that a component has a name, it has a wins against.
That's
A wins against vector of string.
well, a vector of component.
No, string. Yeah. So and the strings would match names.
And then we at some point had to lose against. I don't know if we kept.
A loses against vector of string. Yep. And that is enough to like for I mean it's a little awkward because later later components need to specify more and more and more of what they win and lose against, but
Right, and also, I mean, Rochambeau is nice in that only rules you need on a component is a list of names of other components.
yeah.
You don't need like special mechanics. Like what would happen if you wanted some kind of special mechanic? Like, okay, this component you actually get to wait until your opponent reveals their move before you have to play this one, right? Like if you want to add a mechanic like that, how are you supposed to do that in the system? You can't.
You don't add that in the component. No, that's just
right. You either need to change. You need to change. You can change this struct, and you can change whatever function is interpreting the game.
Yeah.
Choices.
But then you got a different game.
Right.
Yeah.
So for this game, luckily we don't have to deal with very much there. But there are definitely going to be games where you could put names of, you might have like, trample, like all sorts of stuff like that,
Right.
Okay. Yeah, this makes sense. So you've got a format that's has a list of moves. The list of moves is a vector of components. Components have a name and a against vector.
Yep. Yep.
And then, okay, so back to move. A move is
a component.
Component. Yeah, it is a component. Now we're going to need to make sure we validate that.
Right.
Is format, which we already have on our list. So
yep.
I was doing that before by redoing it, but it's better to do it. Better to do it in a validation.
Is the offer going to need a format? No.
I think it will eventually. I think it will if there's a possibility of more than one format.
So there's a couple ways to do it. Format could be a sort of configuration variable, and I think actually this is the way to do it. Every time you run this program, you have to select a format. So the format is in like the global configuration.
Okay.
When this
in the launcher,
like, yeah, you're launched with a fixed format.
Yeah, or a fixed set of set match game elements, right? Format, except not components, I guess. Well, you could even do components.
Well, if a format is a vector of components, then launching a format means launching with a vector of components.
Right. And a game and mode.
Yes.
Is that all of them?
Well, in a mode, like the game will have like implicitly is running this code, right? So the game has been chosen.
Right.
Really, all you actually need is a format and a mode, eventually, and we don't have to do modes yet.
Yeah. Well, but you can. I imagine that it will be pretty useful for people to clients that can do a few different sets, not
Sure.
super
Oh yeah. No,
dramatically different
totally.
things,
Totally.
but things that do let people use different client variations of.
Sure. Yep.
Right. If you want to start with 40 life instead of 20 life, that's a different game.
Yeah. Yeah.
So people making clients could create what guidelines for what types of rules their client can run, let people.
Mm-hmm. Mm-hmm. So in any case, format. How are we going to get formatting here? We have to like choose what kind of thing we're making right now. And I think it makes sense to just make a game that is launched with a specific format, and that's just in the ether.
If that's just from the launcher, then we probably don't need.
We need the type.
We still, because couldn't we just have the component? We have a component here. If we have, if we're being fed the list of components,
we'll need it. We'll need it in order to validate that the component
that's
is
true.
on the list.
Okay, so we will need the format for validation.
Yeah.
Okay. So what else do we need here? The move also needs all this stuff. It actually has a bunch.
Yeah.
Address of commitment.
Yep.
It needs the address of the commitment's author, which is the challenger.
Yep. Let's call these challenger ID and host ID.
Yeah, that actually makes sense because they're agent IDs right now.
Yep. And I'll change that on the other one.
Cool. And then we need the hash from the commitment. Which is hash string. Maybe we just call this hash. Sure. Yeah, definitely, because there's a different thing called move.
Yeah. Move is a keyword. So put an underscore on the end of that.
It's a keyword in Rust?
It is.
Oh.
Yeah,
move,
so when you,
like it's what they call changing ownership.
Yeah, so when you start a thread, there's some magic that happens about when the thread references things outside of it and whether or not it's a borrow or a move. And so sometimes you have to specify that you're going to move.
We maybe don't want to call this move because the struct itself is called move.
Oh, I see.
Anyway, like, do we just want to call it component?
Sure. The component that the move is selecting. Yeah. Yep. A move consists of a component that has been chosen. Yep.
Commitment address, a challenger ID, a commitment hash. Hashing.
Yep.
Okay, then got one more, which is result. And
wait. Does it need the... Oh, I see. Yeah. Never mind.
Oh, wait, let's write down the validation.
Yeah, so we need to validate a bunch of stuff here.
This is the biggest.
Yeah, we need to validate that the move author is the
host.
What the commitment says the host ID is, yeah. Move author is commitment.host ID. Yep. we need to check that the challenger ID is the commitment author.
Commitment author.
Yep.
We need to check that the hash commitment, or sorry, the move.
Or we call it, should we just call this hash here?
We could, yeah. I mean, it's a little bit.
It's the same thing.
Yeah,
it's the same data.
Yeah, it is clear if we do this. Move hash should equal the commitment hash.
Yes.
Yeah, yeah, I like that.
Yes, because it's the same piece of data.
Yeah. Should equal the commitment hash, right? Yeah, and then yeah, so those three, and then something we won't need to do for this game, but other games might have to do.
That the move is in the format, or that the move component is in the format.
Right.
Is in the global format.
Yeah, move. What's the symbol for that? How do I do that? It's like an E.
Oh, I don't know.
There's like there's a math symbol for it's in set.
Yeah, the curly E.
Yeah, yeah. Move component is in
the format.
Right, which is just its own thing.
And we haven't figured out how we're gonna represent that yet, like where it's gonna live. So this is good enough for now.
Yeah, yeah. It says, yeah, probably then the offer should have.
We'll get to that when we start writing the validation method and.
Right. Okay. Fine.
Yeah.
The format somehow needs to get into one of these structs somewhere.
Not necessarily the struct, but the methods that are doing the validation need to be able to reference the correct format somewhere.
Right. I guess that's what I mean.
Yeah. Yeah.
Okay.
It needs to be available for validation.
This is 4 things now. Oh, is that too many? Up here we only had. Oh no, yeah, that's 2. And then we had this thing which I need to put in.
Move valid at this state of game. Right. Right.
It's basically
any move that's in the right. All moves.
I think it's important.
When a move is allowed, all moves are valid.
I think it's important because it's important to notice that actually the move and the game result require a similar type of validation here.
Yeah. Yeah.
It's just that at this particular game, there's nothing to validate for that at this point.
Right.
And then there is at the end. But in a lot of games, this loop will be important.
Yes. Yeah, and it'll be much more complex.
Yeah.
Whether or not the move is valid will be much.
You could think of it as happening in this hash too, but it's just not necessary because that's part of number 4.
Not only is it not necessary, it's impossible.
Right. Yeah.
Yep.
But but if they try to if they commit a hash for an invalid move, then the whole loop breaks and they're gonna have to do it again.
Right. It's just deferred.
Oh, actually, is that an abuse? That's a question.
Is that an abuse?
Yeah, because I submit an invalid hash, but you don't know it's invalid yet. So you commit your move. I go, oops, I screwed up.
And then you forfeit. I mean,
that's not much of an abuse.
We're gonna have to come up with rules of like if somebody just abandons a game, how long before someone can commit I win by default, by forfeit, or whatever.
Yeah, and I think the solution to that is pretty easy, which is if someone submits an invalid hash, then we can just make them lose the game.
Right, exactly. I mean, this is like
the only people doing that. Yeah, the only people doing that would have to be either the program has a bug and it's just broken, or someone's like truly hacking. So
right.
So it's not like something that's going to happen accidentally.
Right.
Yep.
Totally. Yes.
Right. Okay. So we've got these 4 things. Let's talk about the results.
Results. Yeah. A result
needs
a move.
Right. It does need a move. It needs a component. right? I guess is what we're calling that.
No, it needs a move. The move has a component, but it needs a move, which is an address of the move entry.
Oh, that's what you're saying. Oh, but now we have to do that.
Yep.
Address. Yeah, so it's going to have that.
Yep.
It also needs it needs a component too, because
it'll need to go check
because
it needs to get the move anyway, so it can get the component out of the move.
No, I mean it's not the same component as this.
I
it's
see.
It's the opponent's.
I see. Right,
move.
right. Of course.
The opponent's move.
It also needs a nonce. In order to validate the string, you need to reveal the component that you chose and the nonce.
Oh, right. Okay, sure.
So whether we could call this a reveal, we could make a new struct that is a reveal, and it needs a reveal, which has a component and a nonce.
Yeah, I think that's. I did it again. Nonce is just okay.
Yeah, where do we have that?
Just right above
commitment. Oh, commitment, we just have a hash, so we.
Yeah, this doesn't need it because the nonce and the component will be combined into hash string.
Right. This is the first time we've identified the type of nonce, and string is fine. Yeah.
So I think this is really the only reveal that happens in.
Yes. So right, we need a reveal.
That's that might be all we need. No, address of number 3. That's this.
Yeah, no, right. We don't need to pull anything forward for future moves on this one.
Right, so it's simpler.
So we just need the move and the reveal. Yeah, I mean, like, and then we can validate that.
Validation here is that we need to check the reveal.
Right. So the hash of the reveal.
Hash of reveal equals move hash.
Hash. Yes.
Put in the.
Yeah.
And then we need to confirm
the author of the result.
Oh, right. So it needs a result too. It needs some kind of game result. Like, did someone win? Who won?
I mean, this is a design question. This is enough to tell what the result is, right? This is enough data.
That's true.
Any client to display this as a win, lose, or draw.
That's true, but
it's probably nice that requires the client to know how to interpret the rules. So it's probably nice to just do that all at validation time and let a super light client that forgot how the game was supposed to be played still understand. Like a mode, you don't necessarily want your modes to know the game rules. So I'm talking myself into this not being enough, and we do want the sort of like quote unquote game result.
Yeah, it does seem easier because it seems like people might want to do all sorts of things with the results, right? Display them in all sorts of ways.
Yeah.
And it just makes it easier to do that if this is not a required step.
Yeah, totally. So we want a.
So this is probably also its own type. As it needs.
So result might be an enum. So let's say result is an enum that has either.
So the obvious ones are win or draw.
There's a winner or draw, right? And each of those, a win has a reveal and a move, and a draw has a reveal and a move. But a win. Yeah. But a win also has a winner address or a winner ID and a loser ID.
Oh, you don't need both, right?
You don't. Well, You might for validation that it referenced the right person.
Um,
How do we know? How do we know that How do we know who the other player is?
well, so we should know it from the move address.
Okay, right. Sure.
We do have to go back and get it, but this does have both,
For
right? Because
validation.
it
That's
has
fine.
it has the author of the move, and it
Yeah.
also has the challenger.
Yeah.
Author should be the
Totally.
host.
Yep. That's right. That's right. So then the other one is the loser ID. It might be nice not to ask clients to do that check.
Yeah, I think it's good to do that.
Yeah.
Because again, it makes it so that the display results, all you should need is data. You shouldn't have to get this data and then look up more data.
You shouldn't have to know the structure of our game to display the results.
You will still have to look up this stuff. Like the agent ID is just going to
Yeah.
be a random number. So if you want like their
Right.
nickname or whatever, then
But
you're
actually,
going to need to look that up yourself.
the result interface could probably be identical for every game. We could probably require every game to have a result in this.
Yeah, I do think it makes sense to have some kind of standard format for results. It don't all have. There could be some options in there, but
Right, a result. I mean, maybe
some
the result is
standards.
it could be a win, it could be a draw, it could be a forfeit, it could be a abandoned game. There's maybe a bunch, but
Yeah, I mean, if we wanted all that stuff to be here, it would be helpful as well if we had like this.
well, the ID has the nick.
It does, but you have to go. Oh, that's true. Right.
But that's universal to
this
holochain.
isn't. Yeah, this isn't an address.
Yeah.
First, I was thinking it was an address again, and they would have to look up the address to find out like their
Right.
nickname.
I mean, as long as that's the same for every game, which it is because it's holochain, then that's fine.
Yeah. No. Yeah. The agent ID.
Yeah. Yep. So a draw has a reveal and a move.
And then it shouldn't need.
You probably want to keep the host and the challenger.
I guess that's true. I mean, you have them in here still because you've got. Well, I mean, you have them, but you have to look back.
Our game.
Yeah, you have to look back to find them, or you have to look up the header. So
yeah, right.
Okay,
I think it would be convenient to have the host and the challenger.
Although then we're not including who was the host and who was the challenger here.
So I think for a game result, it doesn't matter.
Yeah, we're assuming that they're just arbitrary names, and then nobody will care.
Yeah, and actually, in this result, we probably just want to say players and make it a vec.
Yeah, so let's make player one the host.
Oh, I think just players, and make it a vector because maybe games have multiple. Like if we're designing result for any game,
sure, yeah.
This format could work for any game, and then all of the game results are the same. So modes don't have to know about the game in order to display the results. Yeah.
Would you put this way, or would you load these vertically?
I tend to aggressively explode vertically.
Oh, I feel like I like readability.
Yeah, there's no benefit for
the performance
for that kind of brevity. Cool.
Okay, so then the validation, doing this, and then we're also confirm the results against rules.
Yeah. Confirm that the result is correct. Yeah.
Right, but we're specifically confirming correct in terms of, like,
yes, right.
We're not confirming that the addresses that should all.
Yeah, right. So if at this point the hash of the reveal is the hash of the move, or the what was committed to before, then we have everything we need to know because we've got a move
got the reveal. We've got, so yeah, basically all we need is this component and this
Yep.
that stuff.
Yep.
Should have both of those.
Yep.
Got the address for the move, this one, and the move is by the
Yep.
host.
We've got
the move is made by the host.
Yes.
And then we've got the reveal and this by challenger.
Challenger. Yes.
So we have the
enough
info we need.
information to track the results. Yep.
Nice. So this is already seems much better than the setup that I had before. So that's feeling good.
Good.
Cool. And it is 2:30 on my end.
The only unanswered question is how the format gets into the program.
Right. This is not something that I've done very much in Rust, like universal variables.
Right.
So I don't really know what the good ways are of doing it.
So,
but we can talk in the abstract at least.
Yeah, I think where the format is going to be stored is going to have a lot to do with how it gets in, right? Like,
right.
Is the format stored on Ethereum? Yes. Right?
Right. Yeah. So, I mean, for sure, all of the elements will be stored to some degree on Ethereum, right? The curved bonds will be on Ethereum.
Right.
We could also have a version of them on holochain easily.
Right.
But is that better?
In order to validate that they are what they are, we need an Ethereum address for them. And then we need clients to be able to confirm that this is the thing.
It's easier, I think, with Ethereum because with holochain, if there's some holochain address you need to go get, and there's nobody that is reachable within the network who's broadcasting that address, then you just can't get it, right? I assume.
That situation is like the distributed hash table makes that situation very, very, very unlikely. Like that's a failure mode of holochain itself.
Well, you say it's unlikely, but like we're at a point right now when I imagine almost no one is running holochain.
Certainly, almost no one is running set match games nodes.
Right. So that makes me think the odds wouldn't be that bad for that.
Yeah. No, but we've got to keep all the data up. Because if we're keeping any data on holochain, it's got to be up, right? Like the player that makes the move is not going to be the holochain host that is responsible for keeping it, most likely.
Well, it depends on different data this is why holochain is good for this, right? Data like game results, it doesn't really matter that much if it takes an hour or two, a day or two.
Right. No, totally.
Whereas if you're trying to start a game and it goes, sorry, nobody with this format is online, you can't play. That's a railroad. So the game results, it would be okay, I think, on holochain mostly, and it just takes a little while to come to
for the leaderboard to update. Yeah.
Right. It's a rolling. It just kind of the updates kind of roll in over time, and that's doesn't seem like a big problem.
We'll also want to see how quickly stuff ends up going around. Oh, we've got someone in the chat room.
Oh, sorry if you've been waiting a while.
I can't really read your name. Salt was taken, or Sal was taken. Something. Hello. We are learning from each other. Yeah, we're learning holochain development and trying to make a system here.
Yeah.
Glad you're coming to hang out though.
Yeah, let us know if you have any questions.
Okay. So still, so the format thing is actually maybe a really much bigger question than it's just like where does it come in?
Yeah.
So we might want to mock that up for now.
Yeah, I think it's okay to mock it. I don't know what the answer. Yeah.
I think eventually, one potential answer is like Rust web3.rs and formats are stored on Ethereum, and we read formats from there. And the format,
if it works well, then I think there are two decent reasons to do that. One is
Yeah,
that this stuff is already all going to be on Ethereum because of
totally.
the curved bonds.
Yeah.
As long as like maybe for elements that would have like actually a lot of data, like a game, maybe that won't make sense for
Mm.
some reason. I'm not
But
sure.
the game, it's the sort of game element is only metadata. It's not the whole game. It's not the whole
Oh, is
program.
it? Okay.
It's it's right. It's just metadata that tells what launcher to do what with.
Okay, sure. Yeah, I
Yeah.
guess that's
So
fine.
it like identifies a launcher and it identifies parameters for that launcher, and then the launcher goes and does everything else.
I guess that makes sense. Yeah, whatever. We'll talk more about that, I'm sure, at
Yeah,
some
we'll,
point.
we'll
I
get
want
there.
to make sure that
Yeah, it
I
won't be the whole program.
feel good about that. But so the first reason is all this stuff is going to be on Ethereum anyway because of the current bonds.
Yeah.
And then the second reason is this thing about what if holochain isn't up all the time? You can't.
Yeah.
Which maybe that's not a big deal, but we know that Ethereum's up.
Yeah. You know, now that I'm thinking about this even more, the thing that's on Ethereum could be a holochain address of the format data.
Yeah, totally. But that would
But even
still have
so,
a
we would
problem.
still launch a thing with an Ethereum address that we would go read a holochain address from and get to. Because we want to validate that the Ethereum, because the Ethereum address is like the ID of the, because we're deciding whether we want to play a game based on its economic, based on its like
Yeah, the information that's in Ethereum.
information that's in Ethereum, right?
Well,
Right.
not solely like mode
No, for sure.
mode information also, and if that's not necessarily all stored in Ethereum, then
Yeah.
that would also
Right.
factor into.
Right.
Of course, maybe that will end up getting as well
Right.
for whatever.
But anyway, for now, we can just make a constant.
Either way, I think we can assume that the idea of the launcher grabbing the elements for you
Yeah.
and then feeding those
Yeah.
into the zones. Um,
Yep.
you know, like we don't need to write a function in here to go grab the format off of Ethereum.
Right.
We do, yeah, because we've got what's important is that the two players agree on the format.
Yep.
So I do think we maybe want to have the format offer.
So that's adding an extra layer of complexity. That's now we're trying to prototype a multi-format game.
Right, that's true.
When we don't need to, and I think we want the interface that like this is where like we're asking who's responsible for what. Is the game responsible for choosing a format and letting the player select a format, or is Squad responsible for that?
Yeah, and I think that either of them is certainly capable of doing that.
Yeah.
The question is it dangerous to let Squad do it? Danger.
I don't think so.
Because what if um, I can purposely get into games where our formats are mismatched somehow, and then that somehow causes you have a negative game result.
No, especially if a format is, as long as formats are identified and addressed by either Ethereum addresses or holochain addresses, that won't have.
Well, but only if we confirm that the two players have the same format, right?
Yeah. Sure.
So that's what I feel like.
That's fair.
Somewhere in here, players need to sort of have agreed that they are using the same format.
Right.
Even if that's formats fed in, like you could put the
Right,
address of the format
right. Yeah.
in, put the address of the format in the offer.
Right. The ID of the format.
Right. Yeah, the ID. And then then the commitment happens, that's also an agreement to the format. That's also them saying, okay, I accept this format.
I think you're right.
Format that I want to use.
Let's add
so we don't need to add in all the information from the format, but the address, we do need to confirm that both players agreed to that address as the format.
And have launched their game with the same format.
Right. And I guess that would include that would include all the elements, right? So not components, but format, mode, game, addresses.
Yeah, I think as long as the offer includes a format,
Yeah.
and then the commitment just needs to confirm that the formats match.
Right. Yeah, I was just thinking. So this app is actually the game itself, kind of. So I wonder, don't need to confirm that they agreed on the same game because they're using the same A. That does it
Yes,
for you.
yes, right,
But
right,
that doesn't do it for the
right.
format.
Exactly, yes.
Funny.
And when we add modes into this, mode is going to be added as well. Or I guess no, mode doesn't matter. Mode is just a way to read. We could make a mode that retroactively includes games.
Right. Yeah, that's the funny thing about modes is that they only
Yeah,
the input to a mode is a game result, right?
yeah,
So you don't really need to have known beforehand. Of course, you will
right.
want to a lot of the time, but
But it does mean that results need to implement a consistent interface across games.
right. And to get a valid game result, um, you and your opponent do not need to be using the same mode. What was that right?
No, and I think you don't choose a mode when you play a game. You may ask your client to identify games that will be included in given modes.
Yeah, that's funky. Like, so
Yep,
you could potentially have a system where I'm playing for fun. Like I'm playing a different mode from you,
yep.
but the result is still going to be valid for your mode.
For each one.
Yeah.
Yep, totally. Yep.
Probably they're going to be like on a serious ladder mode. The mode would probably not allow that to happen. The mode would probably say players need to be playing on the ladder or something like
Maybe.
that.
Yeah, maybe.
Because then you wouldn't
Well,
want one player to have high stakes
if
and the
there's
other one
modes that
not.
overlap, whether or not you wanted to play in that mode, you are playing in that mode. If your game result is valid for that mode will include your game result.
Yeah, this is real. This gets pretty confusing. I'm not
Yeah,
totally convinced that we won't want players to be agreeing on the mode, but I'm happy
sure.
to accept that for now. And I
No,
think
I think we
we'll
want
see
the
as we
option
go.
for both kinds of play.
Okay, so we'll just add a format ID to offer now,
Hmm.
and then I don't even think we necessarily need to. Well, should the commitment also have a format ID so we can validate that would be a formal version of the acceptance of that format? Not
Yeah.
sure we need that because just making the commitment is sort of an acceptance of it too.
Yeah, but we will in the result step, we will need that access to that format.
Well, then we want to pass it all the way through.
We will want to pass it all the way through. Yep.
And we'll also need to validate that it's the same all the way.
Yep.
Okay, so add that in. Commitment, that's thing. Ready.
Yep.
Right?
Yes, the game result definitely wants to have the format ID in there for sure.
Yeah, so this is just the format ID is just a completely different thing than this.
Yep. Yep.
Not going to really be.
The format ID is a thing that format.new can take to create a format. So if the format ID is an entry address,
Right, I mean, we could do it that way. We could also, yeah, I mean, whatever. I don't know
yeah.
if it's better to do that in here or to have the launcher do that step and pass in this struct directly.
Yeah, I think it's best to have the launcher handle format IDs.
Yeah, just
It's
handle
less
the ID.
data to put on chain. It's less data to pass around, and then since formats are universal across games, we can ask them each game to know how to resolve the format.
Right. Right. Which is that's a point in the court of storing formats on holochain. And maybe the answer is that they should just be stored on both, and that ideally you get it from holochain. But if it's not available, then you go get it from Ethereum.
Yeah. Sure. Sure.
just because you don't want to launch your game and then have to wait to connect to update a node, an Ethereum node or something like that.
Yeah. I mean, but we're kind of relying on the fact that the Ethereum community is going to figure that out, and if they don't, we'll go use some other chain that has.
It's true, yeah, and they have figured it out as long as you're willing to accept some centralization too.
Right.
Which I'm sure plenty of clients will be very happy to do.
Sure. Yep. Yep.
And right, okay, so that now we need to add this to the validation for each of these. So commitment format ID has to be the same as the offer format ID, and so on.
Yep. Yeah, we need to validate that the format ID matches at each step.
Move format ID.
Yeah.
Result format ID. Move.
Oh, result is a bad choice.
What's that?
Because result is a
Oh, right, because of Rust.
Rust type.
Okay, well that's easy. I'm sure we can just find a synonym.
I like
for
game
that.
result.
Outcome.
Game result.
Oh, but that's messing with my. Because now I want to go game component. Now I want to do that on everything.
Game commitment, game format, game move.
I would rather say outcome.
We have used the term game result in a lot of other material.
We have, it's true.
And this is the sort of universal modes read game results.
Yeah, we have, that's true. And this is actually okay. Here's my justification for why. Yes, exactly. That's my justification for why it doesn't fit in with the other name.
Yep, because the game is going to put this somewhere for other things to do.
Yeah, this data is actually the one that's going to get read by modes.
Yep.
Yeah. Okay. Right, and then if other things need to be validated in this way, they can be.
Yes. Yep.
We want to add the mode to that, then we.
Yep. I mean, I think maybe the way we handle modes is we put in maybe a host and a challenger. Maybe players have intended mode or active mode, and then each mode can decide whether it cares whether or not the player was intending to be in that mode or not.
Right. Yeah, I think that's definitely that's a much easier way for two players to figure out whether or not it's okay for them to play each other.
Yeah. Yep. If they're playing in a mode where it's only people intending to be in this mode, then you set it. But also recognizing that there's other modes that will ignore your intentions and include your game.
Right.
Because somebody might just want to look up the best, the leaderboard of the people who have been playing the longest.
All right, the result also needs to confirm that the reveal component is in the format.
The result does, yes. Yes.
Right, which now, if we want to, we could wait to grab that format until we're processing, like until the move validation. We don't actually need more than the ID until then.
Right. Yep. Yeah. Actually, so this is the thing about cryptography. Like, cryptography, like guarantees past, or like validates past statements. So you don't have to really reveal what the statement is. Enforces consistency of the past, right? So you don't actually have to check until the end.
It's weird. Yeah, it's sort of
It is.
time travel-y and weird.
Yeah.
I mean, that's going back to the initial metaphor of like it is sort of messing with time. Like you're making it so I can prove that what I'm saying right now I chose 2 minutes ago.
Yep.
That's a weird thing to be able to do, you know.
It is a very weird thing, and that property is what makes Bitcoin possible.
Right. Yeah. The whole thing is basically built on various versions of that.
Yeah. Of enforcement of validation of commitment in the past, like the economic side of it is incentives for behavior in the future, and the cryptography half of it is validation of behavior in the past.
Right.
So like as the window moves down, the future benefit, when we're there, we can prove that we acted correctly in the past. Like it's very, very sort of interesting philosophically to just think about how those two things pushing against each other makes this whole thing happen.
And then this is related to why everything that's happening in the space, as varied as it might seem, is ultimately related to hashes, but also basically numbers. I was trying to think of a better word, but like you have to be able to the good behavior that you're proving you did in the past has to be representable somehow. Has to be strictly representable.
Yeah.
And so it has to be somehow. You have to be able to show it with math, which luckily, if it's on a computer, that's everything. So, and actually, computers can do a lot of things, as everybody knows now.
Yeah.
But there's of course still lots of types of behavior. You can't. It's not like you could prove that you acted in any kind of arbitrary way a person can act, right? It's
no, of course.
It's types of ways that
like those
be represented in a computer.
Those supply chain applications. It's like, yeah, we can confirm that they said they put that thing on a truck,
right? Yeah.
At that time, but we don't know that they did. And we can confirm that they said they didn't use pesticides, but we can't confirm that they didn't.
Right. And it's almost impossible to get around that. Like you can get as fancy as you want, but unless you're gonna. It's the
same thing with paperwork, though. I mean, so the paperwork you can retroactively fake.
Oh, I know. Right. Oh, paperwork.
All right. So are we kind of set? Are you in a good place to kind of?
I think so.
Rip apart what you had and start to dig into this?
Yeah, I think so. I think that we'll end up with a much better version of this.